Yes, this is basic geometry. Your flat Earth geometry. Flat Earth geometry. Basic geometry. I called you a flat earther.
My name's Rumpus.
Insisting that your flat Earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a five-sided square?
You walk that road, you'll be left behind. Like swaying branches in
You're a universal horizontal waterer.
lost in confusion.
I called you a flat earther.
You want to experience true level? Do you? Yes? You want to experience true level?
At our level, establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Take it from super flat.
Alright, come on.
There are those who will never see.
Wow, it's
Gift of low gas.
Three coplanar points.
yeah.
I know how water flows,
I called you a flat earther.
and I know what level shows. You'll be wasting your time, mine, trying to change what's been defined. I know what I know. I know what I know. You don't know what you don't know. Blackpool paradox. You think it's measuring, but it's not. It's optical phenomenon. All you fools think you know what's beyond. I know how water flows, and I know what level shows it. You'll be wasting your time, mine, trying to change what's been defined. I know how water flows, and I know what level shows it. You'll be wasting your time, trying to change what's been defined.
Horizon means the line where the sky meets the earth. Yeah, that's the definition I'm going by.
All
And I'm
horizontals are
No, let me
parallel to
finish.
the. And we are live. Welcome, everyone. Today is Thursday, Euclid Day. But on the theme of obfuscation and sophism, we're going to revisit a geometric conundrum that's been laid down to the blue marble science. I guess the model's done it initially. The model dictates that they have to say certain things, and they try sophistry to get around it, pretending that we don't understand their model. But I think most people around here that have been around here know exactly what's going on. So we'll let you into a bit of the geometric trickery that's been going on in the within the Blue Marble scientific realm. Now, I have to let you know, we have been banned from the Blue Marble Science HQ. That's the YouTuber of Blue Marble Science. Now, he has said that he wants to consider Blue Marble Science as a mythical beast. It doesn't exist. There's no such science as Blue Marble Science. Now, Blue Marble Science, the guy on YouTube, wants us to know that. At least he wants to separate himself from the mythical Blue Marble Science. But what we've been doing is we've been studying Blue Marble scientists, and there is no proper, when what Blue Marble means is that it's not a true science, as in it's well, it's like computer science. The actual scientific thing isn't actually there, but the idea of the science is still there. And that's what we're talking about, right? The Blue Marble Science is the knowledge that these guys have gained, or the knowledge that we've gained about the Blue Marble. I mean, we know about it. So that's what we're talking about. When we talk Blue Marble Science with the frantic bunny ears, right? That's the point, that we know it's not real. It's not a real science. It's a completely mythical thing, like Blue Marble Science, the YouTuber says. It's not a real science. It's a sort of, well, taking a mockery out of it. That's what Blue Marble's doing. He's making it into a, I say Blue Marble Science, the YouTuber, not the mythical scientific group of people. Just the well, I don't know, it's like a mythical thing. So you think of Santa Claus and you think of the Easter Bunny. Well, think of Blue Marble Science in a similar way. Not the YouTuber Blue Marble Science, obviously. He's a real person that made a real YouTube channel. Now, what we're talking about is the mythical Blue Marble Science, like Santa, or like an elf, like one of Santa's elves. I mean, you can't give him like a big thing like a Santa. So yeah, mythical. Now, within this mythical scientific group, there's some role players that like to dress up in Blue Marble scientific gear, and they like to parade around Discord channels telling people that they don't understand. It's one of the famous cries of the Blue Marble scientists, that you don't understand. Buster made a song about it. So they go around saying that, and obviously because we've been researching this mythical group of people, or the mythical science, there are real people. Okay, it's hard to you get a bit confused about it. You've got Blue Marble Science, the YouTube character, who, if you go and watch any of his videos, you'll see what the type of Blue Marble Science that he's talking about. But these group of people, the ones that surround this person, Blue Marble Science, call themselves Blue Marble Scientists. And within that, they set each other challenges. One of them, because there's a few people in this mythical group of people, the Blue Marble Scientists, who call themselves FE. I presume that's part of the Flat Earth group of people, also a mythical group of people, just as mythical as the Blue Marble Scientists. So one of them's called FE Dogma. Now, Dogma is like a a taught thing, a rigorously taught thing that is taught as a truth that you just have to take on. So FE Dogma set the Blue Marble Scientists, the group, a challenge. And it's based around LIGO, a straight line, geometric challenge. And now this is a model specific, but it's a mythical model specific thing. So it's really hard. And I call it the twin tangent conundrum. I think, let me... Oh, let me sort it out. There we go. Right, so I'll get you guys in Discord on it first. And then... anybody got any other comments before we start? You guys don't know what we're going on about here today, do you? Anybody got any... So we've been banned from Blue Marbles Science. Blue saved us by banning us from... Quite a few of us. He banned Mobius, he banned Mike Jones, and he banned me. For what? I don't know, he just doesn't want us around. He's got some secret goings on within the mythical group. He sent me a message saying it's mythical. I'll show it you if you Blue doesn't believe us. Right, okay, and if I get this and this. Okay, you guys on Twitter can see it, you guys on the Discord can see it, and this is a video that says Bev's twin tangent paradox claim. If we go back one, this is FE Dogma. He's a YouTube character. He's part of the mythical Blue Marble scientific group. He does a lot of videos, but this one's a little bit more technical. He's got one here that's called Bev's Blackpool Tower Globe Proof. I haven't got a Blackpool Tower Globe Proof, but he likes to make these sort of videos. Now, thus spoke Bev versus photographic evidence. Bev needs to try thinking. So this is over a year ago. And he did a video, was Hanford LIGO built on a flat earth or globe? He still can't decide where it was built. It was just built in reality at Livingston. I don't know why it makes any difference. It was built and certain building procedures. So when he made this video, in it, he placed a tangent, two tangents on one line, and I pointed it out to him. Where's he gone? Oh, where did I put it? Wasn't that far away, was it? Let me see if I can go forward like that.
About a year ago.
Here we go. It's called Bev's twin tangent paradox claim. So just to catch you up, I'll let FE Dogma do this. And I don't know whether you guys have done it, but this will become more apparent in a few minutes when we got past this. So
I uploaded
I'll let
this
this guy
video
do it.
asking the question, was Hanford LIGO built on a flat earth or globe? So I used 5 top of slab elevations for each each arm, which I got from the LIGO blueprints. And then I compared these elevations to both the flat Earth and the globe model of a level line. Now, from a surveyor's point of view, a level line of equal elevation on a flat Earth would be one and the same as a horizontal line, and on course on the globe, that...
So, what he's just said there is, from a surveyor's point of view, level would change. That's like, really, in reality, this guy thinks from a surveyor's point of view, level will change. Bear that in mind.
Level line would curve down from the horizontal line. And with those definitions of a level line, I showed that the beam slab would be a curved line on a flat Earth and a straight line on the globe Earth.
So he's shown that on a flat Earth, the straight line would be a curve. Yeah, so here we go.
Now, 6 days ago, I got this message from Bev on that video. You have 2 tangent points on the same arm. Well, I started my reply with, this is a comment out of the blue. But I added, hopefully by now you understand that those topic grade elevations for the beam arm slab form a curved line with your definition of a level line. But yes, there are 2 tangent points at 2 different elevations, but I only use a single tangent point for each arm.
So he says here, look, yes, there are 2 tangent points at 2 different elevations, but I only use a single tangent point for each arm. Okay, so he does have 2 tangents. It'll become apparent whenever you see this in a minute about his twin tangent paradox. Conundrum. Sorry, it's not a paradox.
Now, a little later, I found out that when I was sound asleep on my side of the globe in Asia, my video was actually the center of a multi-day debate, and this also included blue...
It wasn't a debate. There's no debate about the twin tangent conundrum. Only one of the things that need solving. It's a really tough puzzle to solve, and you'll see.
Marble science and Ruhif standing up for the globe.
Blue marble science.
A few days later, I got a message from Mike Jones. Did you hear Blue Marble taking a beating trying to defend your twin tangent paradox today, little buddy? Well, sorry, Mike. I know you probably want to play bait, but I am not your little buddy. But more interesting is, why do you think 2 lines, each having 1 tangent point at a different elevation, is a paradox? He was stuttering all over the place trying to help obfuscate away the fact that this video claims 2 tangent points on a single straight line. You realize how stupid that is, right? Well, yes, that would be stupid.
Shout out Mike Jones. See it, and he does say it would be stupid.
Well, yes, that would be stupid, but I do not claim that a single straight line is tangent at 2 different points.
Right? He doesn't claim that a single straight line is tangent at 2 points. Remember that, because this is FE Dogma. And he's telling everybody he doesn't claim that. Even though he did say, yes, there were 2 tangent points.
Now, this is the graphic that I use for that arm. So, Mike, where did I claim this arm has 2 tangent points?
Oh, he did that quick, didn't he? Here, it's here at the corner station. Here and here. Here and here at the corner point, right? It's dead easy to say. I'm pretty sure we've been over this many times before. You can't see it.
It has 2 tangent points. So here's a question for Bev or any one of his followers. Can you please provide a timestamp in my video where I have a drawing or where I say the northwest arm is tangent to the 578.33 foot elevation at the corner station? Yes, the southwest arm is tangent to the 533.7.
Here, at the corner, he's turned this around. It was over, the corner was over here before when the tangent was here. Now he's moved it over to this side. This is the other arm, and there is a tangent here. So that's at the corner at the other end of this arm. That's a straight line. It's got two tangents on this one arm. You can't see it.
An
It's turned it.
level line at the corner station, but not the northwest arm. Here's something you guys might want to think about. So line BC is tangent to the circle at point B. And line AB is perpendicular to line BC at point B. Do you really think this means that line AB is also tangent to the circle at point B?
Sophistry, geometric sophistry. He's got a tangent at A. No, like when we go through this, imagine this is LIGO. He had a tangent at point A and then a tangent at point B. He does. That's how he does it. That's why I said you've got two tangent points on the same straight line. It's a conundrum. How do you solve it? You can't. It's an impossibility. But what he's done is to say, well, you can draw a circle on the side. That doesn't put a tangent point at A. It just puts a tangent point at B, but it's a sideways circle. It means nothing. I'll explain it in a minute. It'll come.
But
it'll all come together.
There's breaking news. Now, earlier today, I left this comment on Bev's latest upload. Yes, there is a tangent point at A and B.
Yes, there is a tangent point at A and B. He says it.
Can anyone please give a timestamp on my LIGO video when I say that line AB is tangent to the 533.78 foot elevation at point B? I'll wait. Now, a few minutes ago, I noticed that...
So he says that, and here's my comment again.
Bev replied, there you go. There's a tangent at both A and B. AB is a straight line, and there's a tangent point at both A and B. Finally, we get some honest talking. We all know that's impossible, right? Well, unless you have two different circles. Thanks for being honest about this. So I replied, you're welcome. But there are two different circles. One based on the 529.63 foot elevation at the end station, and the other based on the 533.78 foot elevation at the corner station. So it looks as though you agree with me. Line AB is not tangent to the 533.78 foot elevation at the corner station.
It must be hard listening to this. But he's just contradicted himself. He thinks a tangent's to an elevation.
Yes, and we live on two different circles. Just gibberish from.
Yeah, but this is FE Dogma, and FE Dogma set this conundrum for them by giving them a challenge to solve. How do you have a straight line with two tangent points on it? It's a tricky one for anybody to solve. Go on, sorry.
Also, I just wanted to kind of put it out there. I wonder if FE Dogma is aware that the interferometer is supposed to be on the same plane.
Well, it's obvious that it has to be on the same plane because it's a perpendicular arms. But I mean, I don't know. Go on, sorry.
It's the one beam of light split into at a right angle at the beam splitter. So how can it be at two different elevations on one arm and another? It doesn't make any sense. I don't know if he's ever addressed that or not. Like
Well,
how he
it doesn't really get past the fact that you've got a straight line and it goes from A to B. That's a straight line, AB. He's got a tangent point at A and a tangent point at B. That's impossible, but hey. Because
Blue Marble Science.
we have to put here that whenever we're talking, people hear tangent and they think line, but it's not. It's a tangent point. And the tangent point can generate a line. That line would be perpendicular to the radius at the point it touches, but that's called a tangent point. Now, obviously, if you generate a line at the tangent point, you can't put another tangent on that line. There's no way you can put another tangent point on that line. But FE Dogma has set a conundrum that there are 2 tangent points on this one straight line at LIGO. It's tough, isn't it? I mean, like it's virtually an impossible. Well, it is, and it's an impossible geometric task that FE Dogma has set for the Blue Marble scientists. But I mean, this is how Einsteins are made. Solve a paradox or a puzzle like this, you get you go into the Hall of Fame for the Blue Marble scientists, and FE Dogma's attempting to do it by saying something to do with elevation changes. Now it'll come a bit more apparent in a bit, but yeah, this is where we're at.
Well, I really doubt if he's going to be in agreement with me. But Bev, why don't you try Googling surveying horizontal and level lines? And here's just a few of the results when you click images. So why don't these diagrams match your definition of a level line? And why do they match my graphic that I use for my LIGO video? So Bev, here is something to think about. We know that the concrete slab for the LIGO beam arm is a straight line. We also know that when we use your definition of a level line, the elevation for those beam arms form a curved line. Now,
No. In my definition of level is a straight line on a horizontal plane. It doesn't curve. So how could you use my definition to get a curve? You're mad. People just making up shit. Just because they've got an exploded logical system and they don't even know how to reason anything geometrically. Geometric ignorance, I'd call it. But yeah, I don't have a curved line being level. I don't, and I'm not a flat earther. So again, this is an old video. But he should know.
What are the odds that I could take metabunk Earth curvature calculations, apply them to the globe definition of a level line, and come up with elevations that are within a fraction of an inch of the given elevations of those LIGO beam arms?
He wants to use metabunk to curve a level line. The guy wants to use a calculator made by Jesse Kozlowski. Walter Bislin. Yeah, it is Walter Bislin, isn't it? Or Metabunk. What was he called? Mick West. He made that calculator. And it's only to calculate how much curve you would have to put in a level line to appease a Blue Marble scientist. Geometrically.
For me, this is just more evidence supporting the fact that we live on a globe. And finally, if you are going to continue with this twin tangent paradox, can you or one of your followers please provide a timestamp where I make the claim or have a drawing that shows that the northwest arm is tangent to the elevation at the corner station?
I'll just go back. Here. It says, yes, there is a tangent point at A and B. That's it. There's 2 tangents. on the line AB. 2. You say it yourself. So that's exactly where there are 2 tangent points. So timestamp 3:49 FE Dogma. Blue Marble Scientist Extraordinaire. Right, so you remember that. FE Dogma, the Blue Marble Scientist, the guy laying down the dogma that these guys must follow, has put 2 tangents, one at A and one at B, at LIGO. The straight line. This the straightest thing in the universe, stated by many a Blue Marble Scientist. Right, okay, now change screens. Now we're gonna go to, you guys got that? Yeah, you. Now, this is a bit of a video that I've had saved for quite a bit. And it was it's a thing over at the Blue Marble Scientific Community, Blue Marble Science Discord. And this is where Blue Marble Science and Rumpus decided that it was getting a bit out of hand. FE Dogma was... you know, struggling a little bit with that twin tangent paradox conundrum that everybody else had set. And everybody was having a go at trying to solve how to solve the twin tangent conundrum. Where's Wally? You might have seen it in the Model Affliction Monday thumbnail. He decided to use toothpicks. And he had toothpick tangents in order to prop up a set square on a ball that he'd made. That was Wally. Let me see if I can find some of these. I had some pictures of... I think I had it in here. Right, so let me get the oh, let's see, there's one. Oh. Starcodder's doing it there. See, this one is the a globe hypothesis, and there's the equipotential angle of adjustment. He's got this radius here, and the tangent at the corner point. Concrete slab equals horizontal line, tangent at end station here. The end station, that's this black line along here, and then this one here says horizontal line tangent at corner station. That's this one, the dotted one. So this line here from here to here has one tangent here. A concrete slab equals horizontal line tangent at end station, and this one here says horizontal line tangent at corner station. So here tangent point, and here tangent point. 2 tangent points on one line, and as we all know, like George taught us, what do you call an angle between a horizontal and a horizontal? Anyone know? Come on, somebody must know this.
Equipotential angle of adjustment.
There you go. See, Paper's been researching. George Nutsack taught us that one. And it's there. FE Dogma's just drawn it for us, where he was showing us the 2 tangent points. I do have other pictures of that. He's made the video. You can see it yourself. He did say there was an angle, a tangent point at A and a tangent point at B. And even this one here, this is taken from his video, shows that there is an angle there in between two horizontals. This horizontal, he's even labelled it horizontal. And this one is labelled horizontal. So this is all totally globe, right? This only happens on a globe. It doesn't happen in reality. Just this is total globe. Imagination. He's got two different tangent points. So that's where we're at. Now, okay, good with that, you guys, and I don't think I can up the quality of this because it was recorded. So this is an old video. You can see here at the minute there's Blue Marble Science, Farmer's Boy, and the Rumpus. Three amigos. Rumpus and Farmer's Boy ran away from us when we went to meet them at the... well, we didn't go to meet them. We were there at Bedford and then they turned up and they ran away. So this is Rumpus and what I've titled the 5 laws of globe and horizontal paradox or horizontal, I don't know how Rumpus deals with it. Now, please, if anybody wants to go over anything, stop me at any time. But just remember, this isn't for normal people, right? This is only for the globe, the Blue Marble scientists. These are their laws that they have to stick by. Rumpus is, you know, laying down the rules for the globe guys. So please remember, right? This doesn't apply to reality. It's just Rumpus in the globe, right? Only the globe guys have to deal with this.
So there's just a few very simple points to understand about the globe. One, the Earth
He's typing
in the globe model obviously is a spheroid. Okay, so that's number one.
That's number one. You're following? These are the 5 laws of globe as laid down by Rumpus. He's doing it in presentation at Blue Marble Science.
Would that be would that first one be globe? Globe is a sphere.
The Earth is a globe and the globe is spherical.
Okay, all right,
Yeah,
thank you.
on the globe model, right? He did specifically say that. I'll go let him say it again. Listen to how specific he is, that when we're talking about the Earth as a globe, we're talking about the globe model Earth as a globe, right? Separate it from Earth that you imagine and just the globe model. So here we go. Listen to it.
Just a few very simple points to understand about the globe. One, the Earth in the globe model, obviously.
In the globe model, obviously, right? So that's what we're talking about. We're talking about the Earth in the globe model, obviously.
Is a spheroid. Okay,
it's a spheroid.
One. Down is towards the center of the Earth.
Down is towards the center of the Earth. Yeah? You're all on board with this so far? Rumpus?
Fundamental form, or the fundamental concept, is the distance from the center of the Earth. Now, with just these 3 concepts...
See that? Elevation is the fundamental concept of the distance from the center of the Earth. Fundamental concept, elevation. Remember, it's only on the globe model because in reality, it's just a measured height on a vertical datum, elevation.
we can almost deal, I think, with all of the points that is troubling Bev at the moment. And straight lines are straight, I suppose. Yeah, I suppose that was straight lines are straight. There's another one we can do that. Straight lines are straight.
Curved lines are not.
Yes, and yes, indeed, and good one.
Yeah, it's funny, isn't it? So Blue, as you can hear there, Blue Marble Science is also being involved in this. He's just added a part there within the number 4, straight after straight lines are straight and curved lines are not. So there is a difference between a straight line and a curved line.
Curved lines or not. And I think just with that, I don't think anything need more, but any more curved lines or not. And I think just with those 4 premises, which I don't think Bev understands, 2 and 3.
4's not good enough.
And that causes him all sorts of problems. So let's just deal with this. Right. So if we have right. So let me just get the center. Let me get the center of this. I need to. I just need to.
Tiny Captain's joined.
Get the center of this thing for various reasons.
It needs the center of the circle.
Right. So, and let's draw. Oh yes, actually, I suppose the other thing I should have added here is horizontal is a tangent to the yeah.
I'm sorry. What was that? Horizontal.
Did you?
I think that was Farmer's Boy. Do you want to hear it again? I don't think you don't get to hear Farmer's Boy that much, but that was Farmer's Boy there, so get to listen to him again.
Is a
having his input
to the yeah.
I'm sorry. What was that? Horizontal.
Yep, that was Farmer's Boy.
Did you see Bev talking to Bev yesterday or the day before in their interaction where Bev to a surface, conceptual surface as defined and the other thing I wanted to mention, there was something else I wanted to say, horizontal tangent. Damn it, there was something else I wanted to say about horizontals. Bugger, I've forgotten what the other point was now. Damn it.
It'll come.
It will come, yeah, okay. There's something else I want to add to that. But
See, they're calming him down, relaxing him. It'll come, Rumpus. Don't worry about it. Calm down. No pressure. It's only the 5 rules of globe.
Oh, yes, that's right. And of course, is perpendicular to vertical. So I think
horizontal's a tangent. You do realise that when he says that, he doesn't mean a line, because that's impossible. He's talking about horizontal being a tangent point, not a line. So when he says it's perpendicular, that's a lie, or geometric ignorance, one or the other. I don't know which one, but this we're just talking about on the globe model anyway. So I thought I'd just point that out.
I think that's definitely, but you probably could do without one of those. I've actually overdone it, really. Right, so let's just deal with it. So let's taking this concept here. So here is our Earth. Now we're going to call this. I've used a perfect sphere here, but actually we all know that the Earth is slightly oblique. But we're not going to worry about that, because I think actually SE Montreal made the point the other day that not all verticals don't all go to the centre of the Earth, and I think he was I don't know whether he was aware of the oblate nature of the Earth, but that's the reason that the point is. But anyway, so we'll pretend for the moment.
Did you hear that? I mean, I know it's Rumpus, and I know the way he's talking there. But did you hear exactly what he did? Because I don't know whether you're aware of that, and you may have missed it. It's called sleight of hand, trickery, sophistry, magic. Do you want me to point you back through it? Down is towards the center of the Earth as determined by gravity. And horizontal is a tangent to a conceptual surface by the radius, and is perpendicular to vertical. But they're in his rules. Listen to this.
So I think that's definitely, but you probably could do without one of those. I've actually overdone it really. Right, so let's just deal with it. So let's taking this concept here. So here is our Earth. Now we're going to call this. I've used a perfect sphere here, but actually we all know that the Earth is.
It's not a sphere. That's a circle.
Slightly oblate.
Definitely not a sphere.
Right. Okay. So Rumpus got that one wrong. Maybe he's tricking you. Maybe he wants you to think it's a sphere, but it's not. It's just a circle.
That, because I think actually SE Montreal made the point the other
SE Montreal made the point. What point did SE Montreal make?
day that not all verticals don't all go to the center of the Earth, and I think
so. The verticals don't go to the center of the Earth on the globe model, right?
He was without. I don't know whether he was aware of the oblate nature of the Earth, but that's the reason that the point is. But anyway, so we're pretending.
So on their model, when it's oblate, verticals don't go to the center. Yet in his rules, he's laid out that they do. So he's told you right at the beginning, he's breaking his own rules. That's Rumpus's. And whether you can, I don't know. Whether you're allowed to break the rules like Rumpus does, with a slight trickery, by saying SE pointed out that the verticals on your model don't actually go to the center. And he's like, well, yeah, all right. I'll write it into my 5 fundamental rules of the globe, though, for everybody else to follow. But that's okay. Forget about it. Pretend Rumpus didn't just say that he's breaking his own rules. And let's go back to it being a circle, not a sphere.
For the moment, as a good approximation, the Earth is a perfect sphere. So that's point number 1 done here. Now, point number 2,
that's a circle,
down is towards the
sphere.
center of the Earth. So if I take a point, so let's suppose I have a point here. Where's down? Well, that's going to be towards the center of the Earth, isn't it? So there's down towards there. Okay.
A definitional down. Blue marble scientific methods. He's just drawn a circle. Defined down as to the center. Now we can draw an angled line and call it down. Even though if it was an oblate spheroid, it wouldn't go to the center. Forget about it.
And right, and now we know from the other rule I've got there, the what horizontal is, number 4, from the perpendicular to a vertical, it is perpendicular to that. So let's generate a perpendicular to that. So there we have a perpendicular to that. So if this is a vertical,
it's writing it now.
This must be a horizontal.
Therefore.
But notice it's at this point here only. Only at this point. We call that point A.
See, at that point only.
So this is not horizontal line, the only horizontal point, which is the same as vertical point.
He's doing another magic trick. He's showing you something. You have to be very careful with these guys whenever they do this. Don't be fooled by the visuals. Make sure you listen to what he says. And he's just said again, like I said before, that horizontal is just a point now. Although he does choose to depict it as a straight line and write horizontal on the straight line, even though he just means this point on the vertical line that he's defined as being down.
This horizontal that I've drawn, this horizontal line, is only horizontal at point A. Make sure we all understand that's point A. So,
look.
So we've already.
So he shouldn't draw this horizontal line at all. It is completely redundant here. He shouldn't.
But you have to because you have to though because you can't have perpendicular without lines.
Yeah, the magic trick won't work if you don't draw the horizontal line.
Yep, you can't do a perpendicular point.
Don't forget, this is the 5 rules of the globe by Rumpus and Blue Marble Science. Blue Marble Science is there. Who have we got? Blue Marble Science, Farmer's Boy. I don't know. Hoymar, Judy, the Rumpus, and Tiny Captain. One other that I don't know. So Rumpus is saying this, and nobody's saying, but surely Rumpus, horizontal's a straight line, isn't it? Nope. Rumpus is just reduced horizontal to that point A right there.
Oh, you bastard. So the key point is that it's only at point A that I've drawn this horizontal plane here, or horizontal line in actual fact. But
He's called it a line and a plane, but he's just told you it's only a point.
So it could be one of 3 things. It could be a 2D plane, a 1D line, or a 0D
point.
That which has no parts point. And which one is he claiming it is? The C.
Shay,
point.
Which one is he telling the Globers? They're their rules, not ours,
Point.
not mine. It sounds fucking ridiculous to me. I'd never draw a vertical with a slope on it like that. But this is the rules for the globe. So
it is only point. Only point. He's talking about point.
Well, I mean, he did say point.
Drawing.
Yeah. Yeah, but for the geometrically illiterate Blue Marble Scientist, Rumpus is telling them it can be all 3. So they're going to be really confused unless they get it sorted with Rumpus, which one of those it actually is. Law of Identity's absolutely messed up here. He's telling them all sorts of stupid stuff.
And another thing I think Bev has problems with, he has difficulty for some reason understanding. We're looking at a section, obviously, through the Earth as a sphere. I could draw this as a 3D sphere and then chop a,
He could draw it as a 3D sphere. It's a circle.
But he didn't draw it as a 3D sphere.
It's always been a circle. He thinks I have a problem with it.
Chop a slice through it and then say, here you go, there's this. But we'll just go straight to the 2D slice through the Earth because it's got all the geometry we need to deal with.
It's got all of the geometry we need to deal with here. All of the geometry. It's there. I don't know what he's talking about. I don't think he does either.
So, this horizontal, notice it's also a tangent because, of course, at this point where it intersects with the surface of the Earth,
tangent
by definition, that is perpendicular to a radial. So this vertical is also a radial.
Being a point on the outside of a circle, it's a tangent point. No need to make it any fancier than that.
It's important to understand. In other words, it's a radius. It's a radial line going out from the center to the surface of the Earth. That makes it a vertical, and it's also a radial, which means that this perpendicular line is also a tangent, because a tangent at the surface here. Look at that very closely. There. Let's make.
Can you see that?
Old trick.
It's not a tangent point, is it?
Nope.
It's like right inside. The black line is inside the blue line.
Yes, seemingly they are straight. All are straight. So this is old trick by Rumpus and Red's rhetoric. So.
Well, I would just point out that you can see blue on this side. Therefore, this line here may be a little bit picky, but it's cutting the circle, not a tangent.
It's not picky, I don't think. But
No.
some people will say you're being pedantic and picky, but it's not. It's not a tangent, and it's not certainly not a point.
That different color, in fact. Right. Okay.
It's made it
so
green
that,
now.
by definition, the tangent has got to be.
By definition, it touches the circle at one point and one point only, not cutting through it. It will become a secant.
This is a locally large point.
Even his arrow isn't pointing at it. It's pointing past the green line to the bit of the blue. Terrible. But geometrically
90 degrees
illiterate.
to a normal coming out of there, and it will meet the surface at 90 degrees. It'd be the perpendicular. The radial would be at 90 degrees to the tangent by definition. So that means right, and we also that's how a horizontal is defined. So we've got this is horizontal, which is also equal.
That's how he defined a horizontal. Yet he just made it to a point. You can't have a perpendicular at a point. Horizontal is a tangent to a conceptual surface as defined by a radius and is perpendicular to vertical. Impossible. But Rumpus doesn't know that.
To a tangent. Right, okay, so we've got some basic concepts sorted out here. So what's the elevation of this point A? Well,
Can I just ask
the
a
length
question
of the radius.
real
That's
quick?
the radius of the...
Yeah, go on.
Yeah, so just on that number 4 again. Horizontal is a tangent to a conceptual surface. Can you have a tangent to a conceptual surface?
Well, you need a circle, don't you? A tangent is a point on a curved line where you have the point where the straight line would only touch it at one point and one point only.
I would say it is needed, this conceptual surface, not real surface, but only conceptual, because otherwise he could not defend twin tangent.
Yeah.
Because these circles are only conceptual. On real, if it were real Earth, he couldn't do that. But if it is conceptual, he can make another conceptual surface. So no problem.
That's an interesting point, Paper. I never really thought about it that way. So what you're saying is it has to be conceptual because in reality it would never work.
Will never work, and FE dogma position is undefendable.
Well, hey, this may sound extravagant, but Rumpus may have a plan.
Okay. We'll have to see how that works out. All right, good.
Yeah.
Thank you.
Okay.
Earth. Now, normally, obviously, when we're dealing with elevations, we're talking about them on maps and things. We talk about them being relevant to mean sea level, but that's only because it'd be incredibly awkward to say your elevation is, 630, because this radius is 6,391 kilometers or whatever it is, and also, of course, because of the oblate nature of the Earth, you have to use the water. You have to do it really. It's much more sensible to do it to mean sea level because of the oblate nature. But you can fundamentally think conceptually, the elevation is relevant to the center of the Earth.
Did anybody get that? Because that was a typical Rumpusism, where he just sort of states a load of stuff that's nonsense. It doesn't really mean anything, and he backtracks on what he's talking about. He says conceptually you can think of it to the center of the Earth, although it's not. It's to sea level. go over it again because you'll be confused by a lot of people that say this sort of stuff.
The elevation of this point A, well, this is the length of the radius. That's the radius of the Earth. Now, normally, obviously, when we're dealing with elevations, we're talking about them on maps and things. We talk about them being relevant to mean sea level, but that's only because it'd be incredibly awkward to say your elevation is, you know, 630, because this radius is 6,391 kilometers or whatever it is. And so, and also, of course, because of the oblate nature of the Earth, you have to use the water. You have to do it really much more sensible to do it to mean sea level because of the oblate nature. But you can fundamentally.
Because of the oblate nature, Rumpus says. Because I think whenever you're doing elevations and you reference it to mean sea level, that would be ridiculous if you were using the radius. Because that wouldn't make any sense. That's why they don't use to the center. Because they can't measure it. They measure a 0 point, a mean, on the sea level, because the sea level goes up and down, and they can average that out and get a mean from it. That's why they use the sea level. Just reference it to that one point. They don't then reference that point to the centre of the Earth at all. No fucker does that. In reality, of course, right, the Rumpus is saying on what he imagines occurs on his model. When in reality there is no reference to the mean sea level to the centre of whatever Rumpus imagines. They don't do it. Rumpus does whenever he draws a circle, though. It's dead easy to reference it to the centre of the circle when you draw a circle and then draw a radius. But that's not what happens in reality.
Think conceptually the elevation is relevant to the center of the Earth. So the elevation of point A is the radius of the Earth. Right, that's a point A. Oh, but what is the elevation of a point here? Let's go to a random point here, B. What would be the elevation of that, do you think?
Yeah.
Well, I'll just make sure we've got the exact point we're talking about. So let's pick on a random point here. Arrow, and say, what is the elevation of that point? Right, okay. So, I'm not going to insult. Well, I don't know if people want to. Before I tell people, do you want to, perhaps Farmers or Blue want to say what the elevation, how it's going to compare with the elevation at A?
It will be larger.
Indeed, indeed. So, of course, we can determine that by saying,
be larger. On the globe model, the elevation along a horizontal line would be larger, says Rumpus. Blue Marbles stood up for him as well. It's like he's doing a test. It's a good job, Blue Marbles, there to answer these questions for Rumpus, isn't it?
Right. What's the this? There's the length of the line there. Right. So that's the elevation because it's the distance of B. And let's compare that with what we had. So we can just check how big it is by just doing a comparison. I'll just duplicate and you can see here that if we compare the two, yes, point B, although it's on the same horizontal as A, it's got a different elevation.
How about that?
Ooh. How about that? Look at that. Woo, like a magic trick. It's different length. Who'd have thunk it? We call this one the hypotenuse, this one. It's always the longest side. And it's always opposite the largest angle. And with this triangle here would be a right angle triangle. So this would be 90 degrees. And then this side here would be the hypotenuse, longest side. Woo, it's longer. Amazing. It's like they were discovering geometry. This side of the triangle is longer than this side of the triangle.
Amazing.
It's amazing.
Oh.
They love it.
But it's still horizontal with respect to A. But if you wanted to take that point by itself, it's actually got a different elevation to A. And what's more, we can then do this other thing which causes incredible confusion.
It won't really cause confusion, not for us anyway. But I mean, this is good, isn't it? Right? You've got a horizontal line by Rumpus's rules. He's laid them down here. 1, 2, 3, 4, 5. And he's now got a horizontal with different elevations on it. Fantastic. And Wally's in the chat there talking about... He's always on about Wally. Yeah, Wally's talking about his toothpick tangents. I've already talked about them, Wally. Thanks a lot, though, for pointing out, yeah. We did mention Wally's toothpick tangents solve this problem. He didn't go to half as much trouble as FE Dogma. Or Rumpus and Blue. Watch this, because this is teamwork now.
We can say, what is the tangent? Because this point B defines a new position, a new radius, in effect, a new distance from the centre of the Earth, we can say that it's got its own tangent. Now, this is where this confusion about multiple tangents comes from. And this is what FE Dogma was basically doing in his diagram.
Mm-hmm.
So the tangent, you can argue...
This is what FE Dogma was doing in his diagram.
For this point. Because we know it's a radius, that means it's defining a 3D surface, which means it's defining...
Did you hear that? Did you hear that?
I usually ignore what Rumpus
I know,
is saying.
but say, yeah, people aren't really picking up on it. But if you have to pick up on the little nuances, it's a good job I'm here, isn't it? It's what I do. Welcome. Listen.
Finds a new position, a new radius, in effect, a new distance from the centre of the Earth. We can say that it's got its own tangent. Now, this is where this confusion about multiple tangents comes from. And this is what FE Dogma was basically doing in his diagram. So the tangent, you can argue, for this point, because we know it's a radius, that means it's defining a 3D surface.
Shock? What did he say? Oh, come on.
This is what FE Dogma was basically doing in his diagram. So the tangent, you can argue, for this point, because we know it's a radius, that means it's defining a 3D surface.
Because we know it's a radius, that means it's defining a 3D surface. What's he talking about?
3D circle, maybe. I don't know.
Unless he means a sphere, right? A radius of a sphere defines a 3D surface. Do you reckon that's what he means? Because a radius makes a circle, and a circle's a 2D figure. Unless you're talking a radius of a sphere, and then that would be a 3D surface. But I think, but I'm not so sure whether Rumpus is allowed to say that. I don't know. I don't know who's bothered about listening to any of this technical stuff about the laws of the globe that Rumpus is going over. But it does seem like there's a few contradictory statements that he's making. Worth noting, though. A radius...
Did I miss?
Go on, so go on.
Did I miss the rules? I'm here late, my bad.
Oh, yeah. Yeah, we're going over him, but... I can go over him again in a bit.
All right, all right.
We're just at the bit with the Rumpus saying a radius. Because we know it's a radius... I'll put it back again. Oh. There we go.
Finds a new position, a new radius, in effect, a new distance from the centre of the Earth. We can say that it's got its own tangent. Now, this is where this confusion about multiple tangents comes from. And this is what FE Dogma was basically doing in his diagram. So the tangent, you can argue, for this point, because we know it's a radius, that means it's defining a 3D surface.
A radius defines a 3D surface. Okay? And because he can have a new radius...
Which means it's defining a 2D circle, which means we can define a tangent to it, because quite often one of the arguments used against, has been used in the past by Bev and these other flatties, is that you can't have a tangent to a point, but it's not a point.
You can't have a tangent to a point. And surely Rumpus didn't say that, did he? Has somebody said that? I know I've never said it. Anyone else? Ever heard anybody saying that you can't have a tangent to a point? Because a tangent is a point in it. It's a tangent point. And then you draw a line, a tangent line on the tangent point. It's perpendicular.
Tangent point to tangent point. That's strange, but this is his logic.
Yeah.
2D circle,
2D
which means we
circle.
can define a tangent to it, because quite often one of the arguments used against, has been used in the past by Bev and these other flatties,
It's an argument.
is that you can't have a tangent to a point, but it's not.
That's an argument. He thinks that's an argument that somebody's made, that you can't have a tangent to a point. A tangent is a point. Crazy.
Not a point. It's this point is defining an elevation. If we treat it as an elevation, it's got a radius associated with it of a sphere. And so let's have a look at that sphere. In fact, let's get this sphere, circle we're dealing with, and you can see there. And I'll make it a different color. What are you doing? Just that there. Actually, I think I want to change. Yes. Back. Right.
How's
so
that?
That point B is defining effectively a new conceptual sphere, and as you can see, the extra sides, and it's got this new radius, and so a tangent, and we can then draw a tangent to that. So if I explain that.
And this is exactly what F.E. Dogma did.
Exactly.
This is exactly what F.E. Dogma did. Thank you very much, Blue Marble Science. So this is exactly how F.E. Dogma solved the twin tangent conundrum. How did he do it? Just drew another fucking circle. That easy. You say you can only have one tangent on a line. Well, that may be in normal geometry and thinking. Well, we're talking Rumpus and Globe and Blue Marble Science is involved in this now. And this is exactly what F.E. Dogma did. He didn't mention anything about doing this, drawing extra circles and shit, but well done, F.E. Dogma. It's a good job that these guys are around here, laying down the laws for all of the Globe guys. Where would they be without it? I bet nobody else knew this. You want to put two tangents on one straight line? Just draw another circle. I think I said that to him at some point.
Exactly what he did.
It's exactly what he did.
And so there you are. So we now have point A and point B. And we have two, what we're going to call them tangents, because every elevation, every different elevation creates a new circle, which means we can then define a new tangent. So when we're talking about these other tangents, which is what F.E. Dogma was referring to, he was referring to the tangent for that elevation. And as you can see here, every elevation has a new tangent, has a different tangent.
And as you can see, on the globe model, a horizontal has constantly changing elevations. So therefore, there are an infinite amount of tangents that can be formed along a, well, you can't call it a horizontal line, can you?
I may be
or
confused.
Could you?
I may be confused. Does a tangent have to touch the edge of a circle?
Well, you just make a new circle, like Rumpus has just said. Like if you're struggling with one tangent on your straight line, what you do is you just draw another circle anywhere you want, and then you can say it's got another tangent on it. But they're all different elevations, so really you can draw a circle at any point you want. Say that's a tangent point for your horizontal, so that you've got a new horizontal point. I mean, it is very freeform whenever you get into the geometric understanding of the globe model, like Rumpus is describing here. multiple tangent points are allowed. You just draw another circle.
No doubt.
Yeah, I mean, I don't know whether everybody else is living up to these standards that Rumpus is laying down, and Blue Marble, and FE Dogma. FE Dogma pointed it out. Rumpus is now available to do this, and as you can see, the horizontal point there can be made into horizontal points all the way along this line here, this straight line, by just drawing circles anywhere. And then you could put a tangent point there, and that would make it horizontal, a horizontal point. That's right, isn't it, Paper?
But horizontal point is moving, and when a horizontal point is
everywhere.
moving, yes, it is a line. And moving horizontal, according to this radius, is curved. Sorry, it cannot be straight line, because if you can create at any point this new, it means that it has to be curved, this original, if you are not changing elevation. But if you are changing elevation according to his model, you are changing a circle. You are just pumping this globe.
Just draw a new circle there.
Yeah, but you guys lost me a minute ago. What's a horizontal point?
That's what horizontal is in the globe model. Under Rumpus's rules, it says a horizontal is a tangent to a conceptual surface as defined by a radius and is perpendicular to vertical. So the horizontal is a point at the end of a radius. You can think of the horizontal point as being the end, not the center part, the other end of a radius. Conceptually, within Rumpus's and the globe model, obviously, Rumpus wouldn't just be telling people lies about the globe model. This is actually how the globe model works. And a horizontal point is at the end of a radius, wherever you want to put the radius, anywhere. You can make this radius any length, Rumpus says, and you can put the end point of the radius anywhere. It doesn't really matter. It goes anywhere. And then at the end point there, that's horizontal, according to Rumpus. As Rumpus defines it, that's it, isn't it, Paper? You agree with that?
Yes, but this is point. This line is redundant.
Yeah.
You shouldn't draw this horizontal line.
Yeah. There's no lines there. It's just a point at the end of a radius, wherever you want to put that. It doesn't really matter. It doesn't even have to be within the confines of your original circle with the radius laid out. You just change the length of your radius at any point and have a new horizontal point. Blue Marble Science Geometry, as laid down by Rumpus. And this is like Blue Marble says, this is exactly what FE Dogma laid down for them. And this is why Rumpus is doing it. FE Dogma's laying down the dogma, and Rumpus is now letting everybody know. I don't know why this didn't take it up. I don't know why Neil deGrasse Tyson hasn't done a thing on this. You'd have thought he would have done. You'd have thought every Glober would have had this as a handbook, like a little app that tells you where the horizontal point is. Actually, the horizontal point can be anywhere. Because on this model that he has down is towards the centre, that's every direction. Every direction. Which means that at the end of the radius, every point is a horizontal point.
I'm still confused, man. They must be using the word point different than I'm accustomed to. Because I didn't know it could have that kind of orientation, just a point.
Well, like we say, if you're going to define it this way, then vertical is every direction and horizontal is a point on every part of the vertical line. So also, everywhere is horizontal. There's literally there's no differentiation between any of the orientations on the globe model. Can't tell. Every direction is vertical and every point everywhere is horizontal. Guaranteed. Rumpus's definitions of the globe model. Should we carry on?
I mean, I'm still confused, but I guess so.
Well, I don't know. Are you bothered? I mean, I know what vertical and I know what horizontal is. And I know that every vertical line will be perpendicular to horizontal, and horizontal is a plane. It's not a point. And vertical isn't every direction. It's particular. It's a very definite direction. Same as horizontal. I don't have these problems. This is the problems generated by Rumpus. And I hope the globe guys can keep on. But I like to live in simplicity myself, with my understanding of vertical and horizontal being perpendicular. Rumpus is changing it. Well, I say changing it. It's been like this for 2,000 years, I think, for the globe. I'm not so sure whether many people are aware of it. Like you, Jeremy, you've been in this for how long, and you sound confused.
The horizontal point has got me confused because I didn't. Even if you want to think of it as a dot, or it's that which has no parts, but like I don't know how they're using the word point now because, yeah, you can't orientate a point. It must be a sphere. What are they doing? Like spherical geometry or something? I don't know what this is.
Do you know what a tangent point is? That's what it's based around. Do you know what
where the line meets the circle? Yeah.
Okay. Now
the spot where the line touches the circle.
Okay. Now imagine that you can alter the radius of the circle. Where's the tangent point?
I mean, I guess if you're going to draw a straight line parallel to the other line right above it.
If you have a free form moving radius, right, that can alter in length, where's the tangent point going to be?
Oh, right are they doing? I don't know.
Literally anywhere, right? Because you can move the radius to wherever you want. And so therefore you can put a tangent anywhere you want. And that's where he calls horizontal.
I was almost going to say where the radius touches, but then I'm like, you could just do that anywhere. So I didn't even know how to answer that. Yeah.
That's what Rumpus says horizontal is.
This point where the radius touches the...
Yeah, and it can be anywhere because he's just shown us here that he can extend this radius wherever he wants to have a new tangent point on the tangent line that he originally made. To make a new tangent. Now, this is one for the mathematicians. As you can see, he's drawn one and generated a new tangent point. And then that new tangent point, obviously, makes a line there. And you could have another tangent point on the same vertical here. So by Rumpus's rules, you could have a radius with two tangent points on it. You could infinitely do this. And I call it an infinite expansion of points. Because this... Obviously, this one here generates this one, and then that one generates another one. And you could keep going. Infinite expansion. Could you do an infinite regression of that thing? Because mathematically, if you can go infinite expansion...
Yes.
So you go all the way down to the center...
Infinite progression in this model is possible, but regression no, because you end in one point. So it is not infinite.
Well, that would be the monad, wouldn't it? If you would be able to regress it, you'd be able to regress it back to the prime point where horizontal and vertical are the same point. They're the same thing at that point, the monad.
Yeah, but still, even on this tangent point, the vertical and horizontal are the same. So whole line is vertical and horizontal at the same moment.
Yeah.
No, that's awesome. Then you got it. Then you just have a point in the middle if you regress it all the way, and just every way is horizontal off of that.
Right. So
Or I
what
don't
does
know
that
what
mean?
happens.
What does that mean?
I don't know. This is hurting my brain.
It means that the orientations of vertical and horizontal are absolutely meaningless on this particular model that Rumpus has made. Because every point can be horizontal and every direction can be vertical. Meaningless. Absolutely meaningless. But this is Rumpus's and Blue Marble and the laws of globe. He's basically telling you it's a load of bullshit. But hey, if you want to be geometrically illiterate, right? Like you have to be, I think, if you're a globe model believer, because Rumpus is telling you that it's impossible. Can't happen. Doesn't make any sense. Even when you're trying to comprehend it, Rumpus's idea, it's impossible. I'll do the paradox bit.
And if they're in different places, a new tangent. Every point. Let me go back to this diagram.
Yeah.
If you look at this diagram here, go ahead, Blue.
Go on, yeah, you could also have on that. Go back to your
go back to
previous diagram. Yeah, you could on your original radius line there. If you can extend that out and have another tangent up there as well, which
look, Rumpus is telling him he can extend the radius out and he can have another tangent up there as well. So who says you can't have two tangents on a straight line? Rumpus has put one over here and Blue's about to put another one on the same radius line. Fantastic, this globe stuff, globe geometry.
Would be parallel to
the first
tangent you drew, but only along that radial line.
See, you could have two parallel tangents.
Parallel points?
Parallel tangents on the same radius, yeah? It's fantastic. I mean, most people don't know this sort of stuff. It's on the globe model, Jeremy. Don't be thinking it's got anything to do with reality and normal geometry. This is completely different. Rumpus is laying down the law.
I mean, it sounds like you could have unlimited parallel tangents on one radius line.
Yeah. It is globe. Very globe.
I still don't know how to use the word point.
That of which has no parts. At least that's what we're using. But I mean, you may be stuck in your, I don't know, your geometric thinking, right? It may be limited, Jeremy, to reality. That might be where you're missing out.
No, it is, because this is weird, yeah.
Definitely weird.
Here we go.
Where did you want me to draw this, Blue?
You don't have to.
Go on.
You don't have to
draw
do
it,
that,
Rumpus.
I'm just pointing out that, that first radius you drew can extend vertically as long as you stay along that same line, that same radial, to a new elevation, and you've got a second tangent point.
Absolutely. Go here.
And that tangent point would that tangent line at that point would define a
point
line
or line. This is, again.
I know, yeah, it's very ambiguous, isn't it?
Point or line. Is it a tangent point or is it a
all
line?
line? It says point or line. Blue Marble says point or line. So you've got to go with what we say.
What do you flip a coin? How do you determine point or line? Which is it?
Well, no. I think he's saying point or line, right? You don't choose. It's both. It can be both things.
Both at the same time.
I think so. Yeah, in multiple places, anywhere along the radius. Not a specific place for a tangent point. Not within this geometry, anyway.
If you stay along that same line, that same radial, to a new elevation, and you've got a second tangent point.
Absolutely. Go here.
And that tangent point would that tangent line at that point would define a line that's parallel to the first tangent that you drew.
There we
But
go.
that's the only place you can have that happen, unless you go antipodal to the other side of the Earth.
The only place you can have that happen, right?
Unless.
Parallel tangent points, lines.
Parallel horizontals.
Yeah. Can you remember when we said this in FE Dogma and I said to him at the beginning, you do realise you've got 2 tangent points on a straight line, right? So not right. Well, Blue Marble's just put another tangent point on a straight line, but not the same straight line that Rumpus put it on. Again? How's he do that? Look at it. He's got a sky tangent. A tangent that isn't touching the circle.
You can do all sorts of things with imaginometry, can't you?
I think that's why he said a horizontal line is a tangent to a conceptual surface. So his conceptual surface is a non-existent conceptual surface, not even on the page. He can't even depict it. It's that conceptual.
Yes, you can imagine that it is there. So it suffices for him.
I don't know whether you can see all of the lines. It's getting a little bit messy. But hey, this is Rumpus and talking about verticals and horizontals, right? All of these shapes here that he's making. Well, not all of them. Some of them are verticals, according to Rumpus's and Blue Marble's definitions, but some of them aren't. Some of it might be horizontals.
And then you can have another parallel one.
So have another parallel.
2. And this one here, A, we'll call this. In fact, we'll call this point C.
Yeah, call it C.
Call it C. See, Blue Marble's
so
fully
C has elevation
confirming all
2,
of this sort of stuff.
Point B, we'll call that elevation 3 actually.
Point again.
Elevation 3. B has elevation 2.
B has elevation 2 and elevation 3.
Elevation 1.
See?
Beautiful.
Good. Yes, it's always good to get things in threes, isn't it? Because that makes the hammers home the point.
See, it's always good to get it in threes, Rumpus said. Because 3 nails the thingy home.
Now, what we can also do is we can say, well, actually, this green line I've got here, that is effectively LIGO. This line...
See? The green line, I hope he recolours it, because there's a lot of green lines there.
I was just going to say.
Yeah, it's LIGO.
Green line.
It's LIGO. This is
On a
don't
side
forget.
note,
Go on.
I was just going to say on a side note on Brandon's one night, I had him drawing so many. I was just messing around with him. I had him drawing like 100 lines on a circle. It was funny. But go ahead, my bad.
We've got one from George doing that. Okay. Right, so Rumpus here has got these lines and he's now drawn them on this picture. I forgot where we're going. Let me go.
Line here that I've got in green. Let's make it a bit thicker.
Here we go. LIGO.
I'll give it a different colour.
I'm pretty imagining, right, whenever they were at the planning meeting of LIGO, not the actual planning meeting, right, but obviously you have the surveyors and then you have the Globe Council meeting. I imagine this is what Rumpus was doing now whenever they decided to build LIGO. Something like this, what Rumpus is about to explain. The plan for LIGO. And don't forget, like Blue Marble Science says, this is exactly what FE Dogma was doing. Exactly this. Rumpus is depicting exactly what FE Dogma was trying to talk about with the twin tangents.
Well, I'll give it a LIGO colour, a bit of a mucky brown or something. That, we can say, is LIGO.
That line.
It may be gone.
It's good.
That one there. So there is LIGO. It's straight.
Uh-huh.
It has an elevation of 1A, it has an elevation.
I know. If you're looking at that and thinking, it's got a great big massive slope on it. Well, remember, this is on the globe, right? On the globe.
And which arm is that? Is that one arm or is that both arm? What? It's got one line there.
It's just imagine it's LIGO. I don't know.
Trying to get into these people's minds is.
It's got a tunnel in it as well. I didn't know it went underground. But I guess we have to imagine it. Imagine it underground, but actually on top. Because I've seen pictures of it. I struggle to imagine it under the ground since I've actually seen pictures of LIGO at Livingston. Rakia took us a few pictures of it. So we've actually seen it. It's hard to imagine that as LIGO because it looks nothing like that. But we'll go along with it. Try your hardest, everybody. Let's humour Rumpus.
2 at B, and all the points between A and B have different elevations. So if we were to draw
all of the points, do you want to hear that again? He said, "Imagine this is LIGO."
effectively LIGO.
This is LIGO.
This line here that I've got in green. Let's make it a bit thicker.
So he's going to draw a line for us to imagine is LIGO, the straightest thing.
I'll give it a different colour. I'll give it a LIGO colour, a bit of a mucky brown.
The universe by most blue marble scientists.
That we can say is LIGO.
Hollowed ground. This, the straightness.
That one there.
There's nothing straighter than LIGO.
So there is LIGO. It's straight.
LIGO is definitely straight. It's one of the straightest things in the universe, claimed by many people. I don't think there's ever anything claimed to be straighter than this. They put a laser in it. That's definitely straight. It's one of the straightest things ever, I think.
It has an elevation of 1 at A. It has an elevation 2 at B. And all the points between A and B have different elevations.
All of the points have different elevations.
So if we were to draw a graph, although this object is straight, if we were to draw a graph here,
there we go.
So if I were to draw a graph in here, where we had along the bottom we had distance,
and
along the top we had elevation.
So this is like what we would call an elevation profile, like we had the other day with a canal, and we showed you that where all of the lines were horizontal, perpendicular to the verticals, the one that Chaiki bent like a dishonest twat. So that's what Rumpus is going to do here now. He's going to draw us an elevation profile.
And I were to plot out. Let's take point A here. So if I had point and
so this is an actual elevation profile.
Put A here, and we put B here. We can see that there's a change in elevation. So we have. Let's put the initial point for. Actually, I'm going to just drop. So we have point A, and I put point B up here, so going higher. You would get a shape. Change colour.
A shape. Straight line.
Like this.
What?
Oops.
You see what he's doing?
Look a bit.
Different direction.
Anyone got any comments?
I'm speechless.
This is a straight line, right? This is one of the arms of LIGO, and he's about to plot it on an elevation profile. Elevation, distance. Elevation, vertical, and distance, horizontal. And it's the straightest thing And it's a straight line, admittedly. He says it's a straight line. Yet.
And he did say elevation was measured against his tangent line. That's not a line, but a point, but a line.
Yeah.
Right. That's what he said. He said that the elevation changes between A and B because that tangent line is straight.
Yeah.
Right. So, and he said that
that's
line
horizontal.
that's straight is straight.
Yeah.
Because one of his laws was straight. A straight line is straight, and a curved line is not.
Yeah. A curved line isn't straight.
Right.
Yeah.
So what he's about to show us, I'm thinking that yellow line to me in the square does not look like a straight line.
It would definitely be a contradiction, like he did say. I think it was his 5th one or 4th one, the one that Blue Marble pumped him with, right? So Blue Marble should be able to jump in now and say, no, a curved line is not straight.
Right.
And you said that was a straight line. It is a straight line, and he's drawing an elevation profile, but for some reason, the straight line that's horizontal is curving. But anybody, can you see the really bad thing? I mean, you have to put your head in.
It is curving in the wrong direction.
There you go. If you imagine that you're absolutely crazy and that you are bending a horizontal, when you plot it on these things in this way, Rumpus has drawn the wrong curve.
Well, the elevation's going up from A to B.
Yeah, I think is the curve that way.
Is the curve that way, Rumpus? Blue? Well, I don't know. Let's have a check. I don't know. Should it be? Should anybody, should Rumpus and Blue Marble know which way a curve, which way a straight line would curve on an elevation profile? Or should they know?
Their model.
Yes.
And if anybody knows, they should know.
Even Paper knew. I knew as well, like, because it's the wrong way. It's concave. We went over this with Zanuck when Zanuck tried to tell us about the rolling balls and uphill rivers. It's because of this. There's a confusion, but it's an upwards curve. It's the wrong curve. Whenever they try and justify this model in their mind, they do it. So I think Rumpus is going to go, oops.
No, you might be right. Actually.
Oh, you might be right.
Yeah, I think you're right. I think it actually does that, doesn't it?
Yeah.
Oh, there you go.
So.
Yep.
Rumpus has just realised he drew the wrong curve. So now we've got a proper curve, the one that's a straight line in elevation profile. And, you know, I have actually done some of this stuff. And I'm sure everybody else knows this as well. It doesn't take too much to understand. But in elevation profile, a straight line is straight. It doesn't change from being a straight line, even when you draw it on an elevation profile. So if anybody ever tells you this, you know that they're talking about a globe model, because this just literally doesn't comport with reality at all. Not a bit. Straight lines in elevation profile are straight lines still. I know it's going to be upsetting for him, and the Blue Marble scientists will be giggling away now. Making videos. Hopefully I do. Please, FE Dogma, make a video. Blue Marble Science, make a video. Blue, I'll take you up on that LIGO one if you can bear to talk to us anymore, since you banned us earlier.
Right, yeah, thanks.
Here we go.
Yes, so there we have a curve that represents this straight line of LIGO.
Look, he just literally just said that. There we have a curve that represents the straight line of LIGO.
Why curved line is representing straight line? This is a question from, let's say, philosophical question. Why curved line is representing straight line?
I don't know. He sounds very pleased with himself. Do you want to hear it again? Because he does. He sounds really chuffed with himself, like he stood back and admiring it. He's
Yes, this finished, perfect art, let's say.
Here we go.
Curve that way. Wait a minute.
Wait a minute. Yeah, come on, fix it, Rumpus. Fix your curve.
Yeah, let me just...
Maybe
no,
because
it
it
was
was all
right
the trials and
direction.
tribulations.
Yeah, I think
he had
you're
to
right.
go
I think
through
that
with
actually
this.
does that, doesn't it?
Yeah, I think so.
Yep.
Yep. Right, yeah. Thanks.
I think so.
Yep.
Yes, so there
So-
we have a curve that represents this straight line of LIGO. In other words, if I would...
He's like, look, there we have a curve that represents a straight line of LIGO.
There seems to be some confusion.
Should be doing a display here, right? This would be amazing to watch a load of visitors to go around LIGO and have Rumpus there presenting this of how the curve represents the straight line of LIGO.
To take measurements, as I did, I mean, you saw me compare the elevation for here to there, and they were...
So he did measurements, and you could see how he confirmed with the elevation measurements that he did. Do you remember that? When he put a radius line from there to there, and he compared it with the radius line of the other circle. He compared the radiuses of two circles that are obviously different sizes, and he went, shock, they're different sizes. That was him measuring elevations.
Can I make an observation here and see if I'm correct?
Go on.
So that red line that he said earlier represents LIGO. Here, let me make it this funky brown color.
Yeah.
That one there. Yeah. That is the also happens to be the tangent point slash line slash plane.
Yeah.
Okay. That thing that he said was straight because it's a tangent line, right?
Mm-hmm.
That is the same as the yellow line in the box.
This one. Yeah.
They're the same thing.
Yeah, this curve here represents this straight line here. Yeah. On the globe
problem.
Model. On the globe model.
Obviously no problem with the law of identity there.
Well, obviously for us, but like I say, this has got nothing to do with me. This is understanding the globe model as laid down by Rumpus and the 5 laws. I mean, I'm glad I don't have to live by these 5 laws because it sounds tricky as anything, but hey, the Globers are far more intelligent, or at least I've been told anyway. So they obviously can get a grip of this stuff much quicker.
Well, I'm glad they have to deal.
Us.
Yeah, I'm glad that they have to deal with this kind of psychopathy.
Yeah.
Yeah.
Yeah, this isn't something that they can pick and choose, right? These are laws. These are things that have to occur on the globe model. The globe model guys don't get to pick and choose it, right? You have to go with this, or, well, I don't know how. You'll have to have a word with the blue marble scientists. They don't seem to take too well to questions about it. I know that for a fact. I've been asking them questions about this sort of stuff for quite a while. And I just get told that I don't understand it. So they're right. If you don't understand it as well, then, well, you might be in the same camp as me. But I'm just glad I live in reality, right? And have a firm understanding of geometry myself. Practical geometry in reality. None of this makes any sense to that. None at all.
This one's bigger, but it would and as it gets more and more, as it goes further and further out here, the change in as this if LIGO was to carry on, say, out to here, as you can see, the further you go along, the more dramatic the increase, and hence this is getting more and more and more. And of course, if you were to plot this current, it would form a circle.
I don't think it would. I don't think he understands a mathematical function. Like, how would you get that to plot a circle? The wrong way? What's he talking about? Right, he doesn't know what he's talking about there, does he?
No,
I mean, that
this
doesn't
line,
even...
this curved, let's say, straight line wouldn't produce circle. It cannot be, because it is compared to this circle.
Yeah,
So,
as soon as you reach this point here,
yeah,
you're just going to be off on the axis, aren't you? You're going to be reaching a, I don't know. Would you get an
negative
asymptote?
curve.
Would it reach an asymptote?
No.
Parabolic function?
I would say that it would reach a point where this curve would be negative. So this
Wouldn't come
curve
back on
should
itself.
curve in different direction. I think so, because how to express this elevation difference?
So this line would actually be a horizontal, just extending outwards. So this line actually would never meet up with itself. But Rumpus said that this line here, the elevation profile, would actually form a circle and meet up with itself. Which I can't understand how you end up with that. I don't know why Rumpus said that. It sounds impossible. It sounds fantastical. And probably sounds impressive. And I hope Blue Marble said, yeah. Oh, yeah. I agree with that. Bullshit. And again, like, just in case everybody wants to make sure, just check it with themselves. Oh, come on. Media play is weird.
This is what FE Dogma was basically doing in his diagram. So the
oh, it's over here, won't we? Media play is rubbish.
going higher, you would get a shape. Change colour.
Get a shape
that look like this. Oops.
How ridiculous does it look now? He's putting the curve the wrong way.
Well, the elevation's going up from A to B.
Yeah, I think is the curve that way. Wait a minute.
Is it? Wait a minute. Blue's second guessing himself because Rumpus has done it wrong.
Oh no, you might be right.
Direction. Yeah.
Yeah, I think you're right. I think it does that. Actually, does that, doesn't it?
Yeah, I think so.
Yep. Right.
Yep.
Thanks. Yes. So there we have a curve that represents this straight line of LIGO. In other words, if I were to take measurements, as I did, I mean, you saw me compare the elevation for here to there, and this one's bigger.
You saw him do the measurements.
Yes, and as it gets more and more, as it goes further and further out here, the change in as this, if LIGO was to carry on, say out to here, as you can see, the further you go along, the more dramatic the increase, and hence this is getting more and more and more. And of course, if you were to plot this curve, it would form a circle. So
there you go. So the elevation profile of a straight line defined as horizontal in Rumpus and Blue Marble's elevation profiles would depict a circle. A horizontal line on the globe model, when depicted in an elevation profile, is a circle. Horizontal is circle. Globe model. Mantra. He even did a particular elevation. He drew that box there just so he could tell you that a defined horizontal within the globe model, when drawn in elevation profile, is a circle. Don't worry though, because an elevation profile in reality is based on a horizontal and a vertical being perpendicular, and it isn't a circle. So make from that what you will.
So then why do they argue with us that level is horizontal? Because with what I'm seeing here, they've said level is a curved line. Now they're saying horizontal is a curved line.
In elevation
case,
profile, it's a circle, yeah.
Yeah, in which case, why are they railing against us when we say level is horizontal? They should agree. No?
But we say it's a straight line.
Yes, we definitely say that.
Yeah.
And they disagree with that. But they definitely, from what I've understood, they definitely don't agree that level is horizontal. I mean, you had a debate with Blue about that.
This is their inconsequence. I don't understand too why they are insisting that horizontal is straight line and level is curved. It produces problems.
Sophistry. Yeah, sophisticated problems.
Yes, and now he's trying to deal with that problems which they produce themselves for the globe model.
Yeah, I mean, what's up with that? If you have to draw a horizontal line in elevation profile as a circle, I mean, why can't you do that? It's for the globe. All for the globe, obviously. I mean, I don't really understand it, but like I say, I don't really concern myself with the troubles of other people. I don't think it's worth it. But yeah, I think, well, we've been trying to have conversations with people about these sort of things, and it gets harder and harder. But it seems that Rumpus and Blue Marble, whenever they get together, they become like a force of Blue Marble Science and Rumpus together. A combined force with an instructional manual for Globers. I mean, this is new things to most people, I would imagine. Most people who live just every day to day they're not aware of these sort of things on the globe. It's a good job that Blue Marble Science and Rumpus are letting everybody know about these sort of things. We should send a copy of this to Neil deGrasse Tyson, I think. All of the top globe guys. I wonder where Simon Dan and Conspiracy Cats. Because this is the rules of globe. They have to stick to it.
You have a curve in terms of elevation to represent a straight line. And all you need to do to understand why that happens are those simple rules we've got here.
Here we go.
Nothing else. I don't think there's anything else I've used except those four or five concepts. 4 concepts actually. Well, the three middle ones really. To get this shape, to understand why straight lines appear to be curved, to understand that all the points on a horizontal line have different elevations. And of course, if you do the revert, and the other thing, of course, to do is if you wanted to imagine this blue line I've got here was water. Then if I drew the elevation for that, so if I were to map, now so this is for LIGO.
Here we go.
And this is for the water, or the ocean or something. Then this line...
The ocean?
Would...
There we go. Drum roll, please. What do you reckon?
A straight line, of course.
Look like this. Last thing.
Look at that.
It would be straight, and it would have a constant elevation. So, in other words, if this is mapping the water, so if you imagine this blue line...
But, see, he's got a problem, hasn't he? Because like we were showing the other day with the elevation profile of the canals, that was a horizontal and a vertical. But he said the elevation profile of a horizontal is a circle. And now the elevation of a water is a straight line. How do you reckon that occurs?
Did he run this past the Blue Marble Science Council?
He's
before
in
he
there.
presented this?
He's in there with Blue.
I'm not so
Blue's
sure.
helping him
I know
out.
that, but are they not paying attention? Are they? What's going on here?
This is what has to happen on the globe model. There's no ifs or buts about this. This is Rumpus laying down the law. The rules, the 5 rules of globe. Straight is curved and curved is straight.
Yes, it means curved represents straight and straight represents curved.
Yeah.
Which is nonsense.
Yeah.
Of course.
Anything you think about anything, just think the opposite and you'll be right. It's globe. Totally globe.
And you can see the distance to the blue line, the blue circumference, is obviously a constant distance.
Right, so here we've got Blue Marble Science, Demonic Davros, Farmer's Boy, I think that's GG Little, Hoymar, Judy Bassett, The Rumpus, and Tiny Captain. And have any of them said, just a minute, Rumpus, are you sure? Nope, not a one. And this is, if you're after the top creme de la creme of the globe people, then obviously Rumpus, he's obviously the top one. He's doing these presentations. I mean, you don't get to do this sort of stuff and have this sort of authority and just go over to Blue Marbles and present drawings like this, unless you are of a high rank. So well done, Blue Marble. I like the way you're doing this.
From the centre of the Earth, it's following a
Blue
circle.
Marble and the
circumference of a
Rumpus.
circle. It's got a constant radius. Following Rule 3,
Rule
elevation is the distance from the centre of the Earth. Therefore, a radius has a straight line. Therefore, this curved water, level water, appears as a straight line of constant elevation.
Do you want to hear that? Because that was very logical statement there that Rumpus ran through from a definition and all of the consequences. It's almost like an axiomatic system that he's developed for the globe there. There we go.
Water? Or the ocean or something.
Come on.
Look like this.
Like this. And here we go.
It will be straight, and it will have a constant elevation. So in other
we
words,
go.
if this is mapping the water,
If-
if you imagine this blue line, you can see the distance to the blue line, the blue circumference, is obviously a constant distance from the centre of the Earth. It's following a circle, the circumference of a circle. It's got a constant radius. Following Rule 3, elevation is the distance from the centre of the Earth. Therefore, a radius has a straight line. Therefore, this curved water, level water, appears as a straight line of constant elevation.
Yeah, so if you consider a radius as having a set distance, right? If a radius is a constant distance, then you can make the circumference a straight line in elevation profile. Does that make sense? Did I sum it up?
For me, it doesn't make sense because you just have radius, length of the radius.
Yeah,
So
that's
you
what he
can-
said. The radius is a straight line and a constant distance. Therefore, in elevation profile, the circumference is a straight line. Isn't that what Rumpus just said?
Yeah,
Go on,
yes.
read it again.
Yes.
Let's go again, right? I'm just...
You
I'm going for all of the globe people out there that are listening. There's 44 people listening in. In case any of you are globers, right? Just to make you understand, I don't want to leave you confused about how Rumpus is going over this. So let's hear it again.
Like this. Last thing.
716. Come on. He said it.
It will be straight, and it will have a constant elevation. So in other words, if this is mapping the water, so if you imagine this blue line, you can see the distance to the blue line, the blue circumference, is obviously a constant distance from the center of the Earth.
Yeah, so that's the radius. So that's the radius is constant of a circle. Okay, that's a given. Good. Next.
It's following a circle, the circumference of a circle. It's got a constant radius. Following rule 3, elevation is the distance from the center of the Earth. Therefore, a radius has a straight line. Therefore, this curved water, level water, appears as a straight line.
Yeah, that makes sense, doesn't it? A radius is a straight line. Therefore, in elevation profile, water appears as a straight line. I mean, why doesn't that relate?
Sure. Yeah. So straight is curved and curved is straight.
Yep.
That's really what you have to remember.
Yeah.
What's straight is curved, LIGO, and what's curved, water, is straight.
Yeah, I think I'm getting a hang of this, Globe.
Yeah.
I think
yeah,
I could. I think I could do this. I could. I could do Globe. Globe. I mean, it makes sense if you want to think that way, that a radius is a straight line. Therefore, you can draw an elevation profile of water with a straight line. I'd call that a non sequitur proof from Blue Marble Science, Rumpus. Proof through non sequitur.
No wonder why they have a problem with all the canal elevation profiles.
Yeah.
Yeah, that because in those the water and the canals are depicted as straight.
And the horizontal as well. The horizontal's depicted as straight.
Yeah.
And
yeah.
What they should do is just draw a circle in the corner and just write horizontal on that, and that should be sorted.
Yep.
A horizontal scale with a circle in the corner. Okay, last 30 seconds.
Of constant elevation. So curves become straight if you talk about the elevation of them.
Oh, there we go.
Straight lines become curved if you wish to map their elevation.
There we go.
Yeah.
Sort it out. Sort it out.
Yeah.
Thank you.
Only through elevation, though, right? Whenever you're trying to reference anything to elevation, then you just have to invert. Like curves, all curves become straights, and all straights become curves.
Got it.
In elevation profile on the globe model.
Got it.
Okay.
Was that anything I missed out there, Farmers Blue?
No, I think you've got it.
I think you got it. Yeah.
I think
you nailed it.
But Bev's going to have a field day with this. I can
Of
hear
course.
You're right.
I can hear the high-pitched incredulity from here, and he hasn't even said it yet.
There you go. So Blue Marble loved it. He didn't miss anything, and Farmer's Boy nailed it. Boom. Straights are curved, and curves are straight whenever you're dealing with elevation profiles. On the globe model, obviously.
Have they told engineers this for their elevation?
Well, you see, that's why I think he specified at the beginning on the globe model, right? Because, I mean, that's specific for this particular little group of people, the fanatics, the globe model fanatics, like Hex and Where's Wally and Blue Marble Science. And, I mean, I'm not too sure about how Hoymar and, all of these other ones, Bacon, whether they'd go with all of the intricate nuances of straight lines becoming curves and curves becoming straights.
Mm-hmm.
I don't know. Yeah, everybody. That's why we've gone over this. So everybody can now go out and ask anybody. You can take this clip with you. Clip a few bits. Take it out with you. Ask surveyors. Ask a few engineers. Ask some draftsmen. Go to your local town planning thing and go and ask them. Ask them if you can see any elevation profiles and say, oh, well, why does this not look like it's a curve? And they'll say, because it's a straight line.
Yeah, you need to tell them your horizontal looks strangely straight.
Yeah, both in this plan and in the architecture or whatever the planning that you've had before.
How is it that you're going to build this thing in reality?
And then we can do these proofs. It's the way logical proofs work, right? So when you check it, you can have what we call a modus tollens. It's through the contrapositive, the opposite of the positive. So you could state that something would happen, like Rumpus says there, that straight lines become curves and curves become straights. You can check that and say, nah, that's a load of shit. And then you can backtrack that back to the Rumpus's original claim that it can't be that globe that he's talking about. It must be a different globe. Rumpus might have got his understanding of a globe wrong. But I mean, that's you have to check it for yourself. I don't want me to be saying check. You make sure that Rumpus is either correct or incorrect yourself. That's the way I'd say it.
But I think that we missed something because in his axiomatic system, let's say, it is said that straight lines are straight and curves are not.
Yeah.
So
that was Blue Marble. We can get to that bit, I think.
But the last part, his last statement was quite opposite. For me, this is fraud and a lie. He's
Great
just
point,
lying.
Paper. Great point.
We have fifth point. Straight lines are straight and curves lines are not.
Yeah, Blue.
And
it was Blue that came in with the curved lines or not.
Whatever, but he wrote it, so he agreed. So completely opposite. For me, this is a lie, not mistake, not false statement of fact or whatever, just a lie.
Yeah. Well, I mean, Rumpus. Like we go over this. Listen to what Blue Marble says.
Another one we can do that. Straight lines are straight.
Straight lines are straight.
Curved lines are not.
And curved lines are not.
Yes, and curved. Yes, indeed, and good one. And curved lines are not. And I think just with that, don't think anything need more. But any more.
That's all he needs, right? Straight lines are straight, and curved lines are not.
There was some nervous laughter there by Blue. Do you think he was joking when he said that? Curved lines are not?
Well, Rumpus added it. Number 4. He added it to his... I mean, is this definitions or is this sort of axiomatic postulates? I mean, I don't know. What would you say? These are the 5 laws of globe? Because, I mean, this is what he used in order to be able to say an elevation profile of a horizontal line is a circle.
Postulates, I'd say. They're not definitions for sure.
Yeah. I like the 5 laws of globe. Because he's laying it out what has to happen. Because these aren't, like, you can't just pick and choose these. Like, whereas it is. It sounds as ridiculous as it sounds that a horizontal line has to be a circle in elevation profile on the globe model. He's not lying. Many people have said that to me in the past. But, I mean, like I say, I keep saying it. Sounds ridiculous. And I know, because I've actually done all of this draftsmanship and drawing, plotting and surveying. I know that a horizontal line is a straight line. And even when you plot it on an elevation profile, a horizontal line stays horizontal, dead straight. It doesn't turn into a circle at any point ever. Straight. It's even there in Rumpus's number 4. Straight lines are straight. And a horizontal line is definitely a straight line. It doesn't turn into a circle. Because like Blue Marble says, curved lines are not straight. So there's no way you can have a circle being horizontal in reality. Anybody else want to go over any other bits? Are we happy with that? Rumpus and the well, how well do you think Rumpus managed to help out FE Dogma and the twin tangent conundrum?
I would say that this is just a fraud. So he's talking about two different circles, and he's creating it. It has nothing to do with elevation profile, because elevation profiles are connected to real things like Earth, ground, or whatever. This is measured elevation from the ground or from other vertical datum, but in relation to real Earth. So it cannot be depiction of reality. So if he was defending FE Dogma with these conceptual spheres, he didn't defend him, because FE Dogma supposedly was talking about real things, but apparently he didn't. So I would say that he didn't defend him, but maybe for Globers it is enough convincing. For me, not.
Right. Now, from this, and obviously on Monday, Chaiki, and through what we've sort of been doing for quite a long time through logic, all of that, are you ready to hear the paradox I've come up with? It's specific. It's remember, this is a blue marble induced paradox. Right? There's going to be plenty of these. Not saying it is a paradox, because obviously, in reality, paradoxes do not exist. There's no such thing as a contradiction of something, like something being what it is and not being that thing at the same time. Can't happen. You can't have a light switch that's both on and off. That's a contradiction. So this is a blue marble induced paradox. And this one in particular is a blue marble induced perpendicular paradox. Right, now this states it is impossible to depict the orientation perpendicularly on the globe model without contradiction. Now, if anybody wants to have a go at solving this blue marble induced paradox, please feel free. It is impossible to depict orientational perpendicularity on the globe model without contradiction. And as we've just seen here with Rumpus, I don't know how many contradictions you reckon Rumpus racked up within his definitions, even given the full realm of definitional control, being able to define it however he wanted. It's still impossible to be able to do on the blue marble model. I'll throw a challenge out, blue marble scientists. Get it sorted. A blue marble induced perpendicular paradox. I'll state it again. It is impossible to depict orientational perpendicularity on the globe model without contradiction. Open for anyone. Give it a crack. Try and work it out. Orientational perpendicularity. That orientation is vertical and horizontal. And perpendicularity, obviously.
Of course, it is impossible because verticals are diverging. So, simple. And horizontal is or curved, like level on their model, or they are trying to save a straight line with local horizontal sections, let's say.
There'll still be a contradiction there, though.
Yes, of course. But for me, the easiest way to depict that is by diverging verticals, because, of course, they are radii. So obviously, radii cannot be parallel to each other. So they cannot establish perpendicularity also.
Oh, don't give it away. Let's have a try. Some of them could try it. Rumpus tried his best, didn't he? It's sort of, I think that's what F.E. Dogma was doing when he initially put the twin tangent conundrum out there. They were searching for mathematical geniuses to come and solve this particular paradox, or maybe not this one, but another paradox that they've probably seen. Because there are many paradoxes. If you want to try, anybody, if you want to try and find a paradox, be my guest. I think this is what we should be doing. We all should be working out to try and find and solve the paradoxes within. Like I say, I don't think there are any paradoxes. And I know one of the easiest ways to solve this particular paradox. Blue marble induced paradox. But I'll leave that up to everybody else. I don't want to be giving too much away. It's not complicated. But it takes a little while for you to puzzle it out. Let me back to Discord. So I thought that was quite good, because we started with the twin tangent paradox, and then this one of Rumpus came out with the 5 laws of globe. And I clipped that a bit ago from it was a presentation that Rumpus gave to Blue Marble Science quite a bit ago about the time of the twin tangent paradoxes. And I quite like the idea of the twin tangent paradox, because it lays down another one of these problems. It's not a paradox, really. It's a conundrum. It's a puzzle to be solved of how you can possibly place 2 tangents upon one line. Because, I don't know, many other people had said it as well, that LIGO being 2 straight arms perpendicular to each other, well, that would lie on a plane, and there would only be 1 tangent point to the plane. But he put 2 tangent points on one of the arms. I don't know whether the plane would have had another tangent point. Whether, I don't know how many tangent points Blue Marble and the guys could possibly fit on LIGO. I'm guessing an infinite amount of tangent points, judging by the Rumpus's definition. LIGO, which still is a thing. LIGO still does exist, so it's a real thing. So whenever you're thinking about these sort of things and you see Rumpus's pictures, you know that those can be checked in reality. And they can be known about. And Rumpus can be proven full of shit. Or correct, obviously. Blue Marble, the same goes for Blue Marble. Some of the claims that these people make can be proved a load of bullshit. Or true. And coming up next week, perhaps, we'll do the run-up to a special, a George Sack special, God rest his soul. Because Blue Marble is, they're not honouring him and giving the full credit to what we call George's final work for the globe. George tried to solve the hardest problem. He tried to solve the horizontal paradox for the globe model with globe differential leveling, double rodding, RBD face, equipotential angle of adjustment. He came up with all sorts of stuff. The Blue Marble scientific crowd aren't giving the credit to what George, it needs to be built on. It's not perfect. It's definitely better than Rumpus and his circular horizontals. I don't think George bothered telling them over there at the Blue Marble Scientists. They keep getting us wrong. They keep telling us that George and his differential leveling for the globe was a joke. They thought it was a comedy routine. The Blue Marble Scientists are convinced that George, when he came over here for 4 hours, was doing a comedy routine. I don't think that's right. So we're going to go over George's last work for the globe. But it may take a week or so for us to get there, because beforehand, I think we need to deal with Jesse Kozlowski and his surveying, so we can understand how George got to the point that George got to finish off the horizontal paradox for the Blue Marble science community. Oh, sorry, yeah, the Blue Marble science, the mythical Blue Marble science community. Blue Marble told us to say that. It's not a real science community, and Blue Marble science isn't a real science. It's a mythical science, as Blue Marble science calls it. Blue Marble science, the YouTuber, has stated that Blue Marble science is a mythical science. Rather like Santa Claus and stuff like that. It doesn't actually exist. There's no such thing. Blue Marble Science, the YouTuber, wants to make it known that Blue Marble Science is a mythical science. It doesn't actually exist. There is no Blue Marble Science. There's no science of the blue marble. It doesn't exist. To just make that clear. Perhaps I should put a disclaimer at the front. Maybe we should do that. When we're talking about Blue Marble Science, we're not talking about Blue Marble Science as though it's a science. It's a mythical science. Let me have a look. I don't know whether I got that.
Pseudoscience.
Mythical science, I think Blue Marble chose to say. Yeah, there it is. I'm sure he won't mind. There he goes. He says, "Hi Bev, the server's fine. I remove you, Mike and Mobius from it." That's fine, Blue. I'm okay with that. Several of us have noticed that you guys are obsessed with some mythical, non-existent branch of science. There you go. So, Blue Marble says, some of us have noticed that you guys are obsessed with some mythical, non-existent branch of science with an unknown group of fictional leaders that are threatening to you. Nobody's threatening. I don't ever heard anybody ever say that the Blue Marble Science Group a community are threatening. Has anybody ever heard anybody say that? It's not. But mythical, I don't know. Did anybody ever here really take the blue marble science tag as a serious thing? I didn't. It's more sort of comedy whenever I was talking about the blue marble science group. But blue marble science says they're a mythical group.
Okay, if these words are his words,
yeah.
So okay, it can be mythical.
Mythical, yeah. So every time you hear us talk of this from now on, just know that we're not talking about a real scientific thing as if it's a real thing. No. We're doing it really as a comedy thing. The blue marble science guys I think of them as a comedy group, a mythical comedy group. But I think George was definitely serious when he did his. There we go. Not really got that much else other than a few little comments. I think, I don't know what this one is. This one. This I was talking to Doofus earlier, and I don't know if anybody knows who Doofus is. He's one of the trolls that you sort of summon whenever you talk about anything in any of these chat rooms here on Discord. It could be anywhere on any of the Discord channels, and you can summon this guy by talking anything sort of geometry, a little bit of surveying. He comes running. He says, the thing that's... I said, you don't care about the laws, because he said he didn't care about what Rumpus said. And I said, you know, I'm doing a show tonight about Rumpus and his laws. And he says, I don't care. And I said, you don't care about the laws? He said, that's the thing you flat earthers don't get. He's mistaken me for a flat earther. He always does that. That's one of his routines that they always do. He says, we're not dealing with unfalsifiable claims here. Nobody is setting anything in stone in science. So Rumpus wasn't setting anything in stone in science when he was doing that. Like Blue Marble Science says, it's mythical. It's a fictional group of people. They don't exist. There is no science of the blue marble. It doesn't exist. He says the description of the equilibrium between pressure and weight in a fluid is both falsifiable and observable. The description of the equilibrium between pressure and weight in a fluid is both falsifiable and observable.
It is not between pressure and weight, for me at least, are the same.
The description.
Yes, but equilibrium between, it means that he has to compare pressure to weight. For me, pressure and weight, they are the same. So basically, so this is no equilibrium between the same thing. You cannot have equilibrium between weight and weight if we are talking about the same object, for example. So
yeah, but he's saying that the description of that is both falsifiable and observable. It just in case you wanted to not understand it even more, add like a squared to the not making sense of anything.
Yes, the description is not observation, so
just literally doesn't make any sense. Like, so people within the Blue Marble scientific community that doesn't exist, the mythical thing, can just make up anything that doesn't actually mean anything and say it. And then whenever you say, that doesn't make any sense, they go, aha, you don't understand it. Yeah, we don't understand it. It doesn't make any sense. He says the same goes for any of the other physics principles people use to know more about reality. They are falsifiable. What's falsifiable? The physics laws.
Yes, how you can falsify laws.
Yeah.
That, for example, that 2 + 2 = 4.
Any of the other physics principles people use to know more about in reality, they're falsifiable. How do you falsify the perpendicularity between vertical and horizontal?
You can falsify only, let's say, experiment. But you are talking about a particular thing, that something was wrong in this experiment and we can do better, for example. But we are talking about particular thing, not about principle. Principles cannot be falsifiable.
Well, they can be if you're Doofus Manfred.
Oh, okay.
An on-call Blue Marble scientist text troll from Discord. He doesn't really come out to talk very much about anything. He just normally, he's a bit of a farmer's boy type character. But yeah, he says they're falsifiable. So all of the principles within physics are falsifiable. Nobody's laying down laws for anybody else. And then I say, it's a psyop. Because he keeps talking about this, the flat earthers. I mean, it's got nothing to do with anything. That's it. Something about people not understanding has got anything to do with physics and the falsifiability, he calls it, of physics principles people use to know more about reality. Just falsify it. Is that... You know, we're going on about how to turn things upside down, right? And you know, I'd say, is it provable? I'd say that. Can we have a proof for it? Well, is he saying the opposite, right? It's just falsifiable. Like, does he mean they're provable, but he's just wrote down falsifiable?
Falsifiable means that you can disprove the proof.
Yeah.
You can say that it doesn't touch reality, in fact. But it means that what you think it was proof for something, for example, that that sun is shining and therefore plants are growing. So you have proof. So he will not falsify that sun is shining and the plants are growing, but he will falsify the causation, that this is not proof that sun causes plants to grow. So that would be his falsification. It's like stolen concept. Yes.
Yeah.
This is first step to steal the concept.
Do you reckon then, because he's talking about physics principles, and for instance, let's say we're dealing with the physics principles of water, establishing an equilibrium and even altitude, right? And I would say that is a horizontal on a straight line. Do you think he's saying that's falsifiable? Because that's a physics principles that people use to know more about reality. Is he saying that's falsifiable? Within the blue marble, obviously.
Maybe. I don't know really, because you cannot know what is in his head. But
yeah, I know. I mean, this is for everybody, right? Everybody's seen that comment. Everybody could have been in the Discord channel and seen it earlier, right? I don't know how many people there are that go through these Discord channels looking at all of these things, and I don't know whether Doofus Manfred is like one of the highest ranking globe scientists there is. Obviously, talking to piss, there's no such thing as a globe scientist or a blue marble scientist, but there are people like Doofus Manfred that come and tell you things about physics and physics principles, you know, in everyday life. So at your best stab of that, would you be saying that the same goes for any of the other physics principles that people use to know more about reality? They are falsifiable.
yes, and this is false statement, because as you said about water level, that it is 6 level, it means equilibrium. It means that this is common notion. We maybe we cannot know why it happens. It just happens. So that thing is common notion. You cannot change it. You maybe don't know why it is in the world that water behaves like that, but still it does behave like that, and this is called common notion. So I would say that you cannot falsify common notions.
But you could prove the straight line, couldn't you? That you could prove a horizontal plane.
Yes, of course. But itself, this equilibrium is a common notion.
Yeah.
This behavior of water. We don't know why water behaves that way. It does. It's just the fact.
But like I'm saying, you know, I'd say that you could prove it to be a horizontal plane. So from what he's saying, it's falsifiable. Or are you saying that you'd be after the understanding of why it had a horizontal plane?
I don't know. Maybe he is talking about common notion itself, because or observed phenomena, which are not falsifiable, because if they occur, it means that they are. So you cannot falsify facts.
So you don't think he'd be able to falsify that all horizontals are parallel to the plane of the horizon? Because that would be another physics principles that people use to know more about reality, right?
Yes, I would say that it is impossible. It is impossible to falsify that statement.
Yeah. So there's every chance that Doofus Manfred is just talking a load of shit.
Yes.
Well, in fact, not every chance. He's definitely talking a load of shit, at least in this particular statement here. Doofus, if you're out there and you would like to come and have a chat about any of this sort of stuff, just to clarify this stuff that you're saying that seems to be wrong. It's like either a misspelling, a miswording, or just outright wrong. You may have been mistaken. It would be good if you could clarify it, though, because I don't know how many of the the blue marble scientists, whether you've actually told Blue Marble Science, the YouTube person, or any of the other ones that have named themselves Blue Marble Scientists under the tutelage of Blue Marble Science. any of this shit. Seems a little bit strange, but again, there are people like Doofus Manfred that are ready and willing to come and talk to you in any chat room on Discord, really. If you want to start talking about level being horizontal, just a couple of comments and he'll be there at the side of you, ready to make a comment about something. Maybe telling you it's falsifiable or it's not that and you don't really know what it is. It may be like Rumpus and telling you that a horizontal line in elevation profile's actually a circle. He might want to tell you that the horizon is a circle and therefore all horizontals cannot be parallel to it. Maybe not understanding about the zero pressure state of water either. And Hex, I did have Hex. I wonder whether I got that. He had a comment earlier. Oh, here we go. Here, this one. This is the law of identity is where we start on the level live. Tuesday, and Hex, I think he commented on it today, so he's been watching Tuesday's Logic show, a little bit behind, a few days behind, but that's okay, Hex. I know you're here like watching it live. He says, we deny universal perpendicularity. We deny that all verticals are perpendicular to all horizontals. And I ask, who do you speak of when you say we? And he says, scientifically minded people like the blue marble scientists. So Hex is speaking for the blue marble scientists, which I know Blue Marble says they're a mythical, it's a mythical science. But Hex, I think he's talking about the people that have named themselves Blue Marble scientists over at the Blue Marble Science Discord channel. So according to Hex, who's in our chat right now, everybody say hi, Hex. He's a real person. I don't employ him to come over, and I don't think the Blue Marble scientists employ Hex to come over here either. But it appears that he wants to become a Blue Marble scientist, where he says the Blue Marble scientists deny universal perpendicularity. They deny that all verticals are perpendicular to all horizontals. Now, I would say that vertical and horizontal are always perpendicular to one another. Always. Every time. So all horizontals are perpendicular to all verticals. Always. Wherever you are, doesn't matter whether you're over there and I'm over here, all of my verticals will be perpendicular to the horizontal. All of your verticals will be perpendicular to the horizontal. My horizontal will be perpendicular to your vertical, and your vertical will be perpendicular to my horizontal. That's the relationship. Vertical, horizontal, perpendicular. Now, I don't know whether you'd call that universal perpendicularity. But I would have to say that I do think they are. In fact, I would have to say I'd struggle to imagine how to say they aren't. Really. And I don't know how many other people are like that. Like I say, just me. I'm just speaking for me when I say that. I have lived in reality for quite a long time, and I'm dealing with horizontal and vertical being perpendicular. And to my knowledge, always, every time, without fail. Although, Hex, when he's speaking for the Blue Marble Scientists, seems to say they deny it. They deny all verticals are perpendicular to all horizontals.
Just have one association that mythologist and mythologist, it is a very similar word.
Well, what's mythologist? Is that somebody who follows myths?
Or producing myth. Instead of science, he's producing myth or superstition or whatever. It sounds similarly to mythologist.
Yeah, I'm keen on not speaking for other people. Like I like to consider everybody as an individual. So when I'm speaking, I only like to speak for myself. Right. But I know other people have said that, you know, like when you are speaking, Bev, you can speak for me. You do have the right to do that. And I know that people have given me that right, but I still find it tricky for me to be able to do that. But Hex, on the other hand, he tends to speak for an entire group of people. And I do know that Blue Marble says that, you know, they're a mythical group of people, but Blue Marble Science, the YouTuber, does have a cult following. I mean, he is part of a cult, I'd say, anyway. He's took the moniker Blue Marble Science and it began to embody the science of Blue Marble. So he's become this Blue Marble scientific person, and the people that follow him over there on his Discord server, I know I've been there, and they are a very loyal group of people. They are Blue Marble scientists, and I when I was over there, I didn't see Hex over there on the Blue Marble Science server, but he seems to be wanting to speak for them. He's saying, we deny universal perpendicularity. We deny that all verticals are perpendicular to all horizontals. And when asked who the we is, Hex says scientifically minded people like the Blue Marble Scientists. But Blue Marble, the Blue Marble Science, the guy has said that Blue Marble Science is a mythical thing. It's not real. So how real are Hex's scientifically minded mythical scientists? I'd say, how scientific is a mythical science? Say around 0? Not scientific at all. So it's definitely not scientific to talk about geometry. I mean, is there any science in saying that verticals are perpendicular to horizontal? I wouldn't call that scientific at all. I'd say that's unscientific to be able to deny perpendicularity geometrically on behalf of a group of people. So thank you very much, Hex, speaking for the Blue Marble Scientists. I know they'll be proud of you. very much, Rumpus, for helping out with the 5 laws of globe. The rules that everybody has to stick by in order to keep from making any mistakes about everything. Just make sure that everybody draws a circle and is completely unaware of any geometric principles or the law of non-contradiction. Otherwise, I'd say you're going to have a bit of a problem. Or you could just come into the On the Level Discord server. I'll try our best to explain contradictions, but the problem with trying to explain a contradiction is that in reality, there are no contradictions. So in order for you to learn about a contradiction, what you have to do is place yourself in conversation with somebody who's holding the contradiction. And then you have to be able to find the contradiction, work it out, find out why it's a contradiction. And in order for you to teach somebody about a contradiction, you have to generate a contradiction that doesn't exist in reality. It's very backwards thinking. And so the only real way that you can ever experience these contradictions is to talk to people that have a contradictory opinion in themselves. Then you have to spot it, point it out to them, see the consequences of it. There's not many people that hold contradictions, I don't think. Maybe everybody holds some sort of a contradiction and it's just trying to show them it. But in showing somebody a contradiction, then what's the outcome? What happens? What cognitive dissonance reaction are you going to find when you do show somebody a contradiction? Who knows? Everybody's an individual. There's no group reaction. It's all an individual sort of thing. It's like the guys are having fun talking to the contradictory agents of the Blue Marble Scientific, mythical Blue Marble Scientific method.
Have they ever shown vertical to not be perpendicular with a horizontal?
No. No, they've never shown a horizontal that's not parallel to the plane of the horizon. They've never shown anything. In fact, they've never even come up with a different definition for what it would be if it wasn't that, because it can't be anything other than that. Oh, here we got a Petey's going to have a go at a logical statement. It's one of those ones that starts off good and then dwindles away, right? So take this. Petey says, if all verticals are perpendicular to all horizontals, then why not have a crack at explaining Wally's Falcon Heavy Supercut questions? It sounded like you were really going to have a go at trying an argument there, Petey. But again, non sequitur, fail. And like I say, I'm not really interested in Wally's videos. And if it's got anything to do with Wally's meme, then I don't know. I think I might have a go at having a chat with the guys at the weekend to see whether we can go over these. I don't know what to call it. Maybe like a what the fuck. I don't really know. It doesn't make any sense. you get to a part where you come into a conversation and you know, we've been learning about the trivium, we've been learning about grammar and logic and rhetoric and how to communicate with each other. And then you get somebody like Wally, and Chaiki as well, for that matter. And Bluey, people like that, the sophists, that they don't seem to be able to form a coherent sentence together, string it together, to keep the rationale together. It's shocking the amount of people that you can have conversations with that will say absolutely nothing, go nowhere. And yet they'll imagine they're arguing some sort of strange point. Yeah, people who are in the chat that don't necessarily get chance to come into the Discord, that we have a very strange group of people from the Blue Marble Scientific, the mythical Blue Marble Scientific group, that you'll forever be chatting to them and they just don't make any sense. Blue Marble Science, Wally, whoever Weatherhelm is, probably Brenda. PT is another guy. They're making videos and stuff. They have little channels where they make videos and they address them to me about things, geometry things. They try and help Nathan Oakley with the angle, tell me what I can do with angles. PT did make a video for us. Does anybody want to see that? So it's 11 o'clock. Let me have a quick look, see whether I've got that one there still. Oh, yeah. Okay. Do you want to go over this?
Why not?
Yeah. Okay, it is geometry, so here we go. Are you guys on there? Can you still see that? Can you guys see that? You guys can in the Discord, in the YouTube. You guys in the Discord see that? It's PT. This is PT that's in the chat. So if you want to get over there, PT194, get over there and he's got answering some of Bev's questions regarding geometry. Remember to check out a couple of recent entries in my community page. Got a community page. Do you have a community page now? We've only got 185 subs, so I don't know. I doubt he'll watch this, but if he does, he won't give two hoots whether globe geometry, there's no such thing as globe geometry, but I mean, we'll let him have that. Whether fictional, mythical globe geometry agrees with reality or not, claiming he doesn't care about the shape. Who is he kidding? If he wants to know how celestial navigation works, then the shape of the body we stand on is crucial. I'm sure he'll pick on a word or definition or something I didn't adequately explain to dissect instead. Predictions in a thing. But the geometry does work for a globe, and it doesn't for any flat-based horizontal model that has yet to be proposed or will ever be proposed. Publish your geometry if known otherwise. I don't know whether PT really understands what geometry is. This video wasn't supposed to be an all-encompassing definitive guide to celestial navigation, more like a little introductory rummage of the geometry for deniers. That said, spot any errors, let me know so I can mention them here. And then he does my video and then the GeoGebra script. Okay, so this is PT, and the video that he said we wouldn't go over. Here it is. What does
I
1
can
degree...
see still Rumpus's screen.
Okay, yeah. Oh, yeah. It's on there. That one.
Now it's okay.
Yeah. Okay. Let me get that. What does 1 degree for every 69 miles? What does that? What image does that mentally conjure up? Because it's geometric. It's a geometric statement. So, what does that geometric picture look like? I don't want to put a downer on it. You do only have an angle, and as we all know, you can do fuck all with an angle.
Hello, I'm back again to help Bev from Try Thinking understand what you can do with an angle. With the help of this geometry software, we'll
Scouser, all right, La.
see how an angle to a star translates to the surface distance between the observer and the ground position of a star. But before we go any further, let me explain some of the items that we've got on view. We'll start with the ball's radius of 3959 miles. This is the observer.
PT, don't use ball. Just a hint. Never use ball. It won't help you in the end.
This is the ground position of the star, which is very local, and it's only a few thousand miles above the surface. The coordinates for both of these are here. The observer's angles to the star.
Did you say the star's only a few thousand miles?
59 miles. This is the observer. This is the ground position of the star, which is very local, and it's only a few thousand miles above the surface.
Yeah, very local.
Yes, you did.
The star is very local, being a few thousand miles. So, is a few thousand miles a local measurement? Are we going to put a local to be a few thousand in the definition of local? Because, I mean, I've never heard anybody else say a local measurement before. So, thank you very much, PT. First, I will remember that PT said that local is a few thousand miles.
But still, it contradicts globe model. So why he is drawing globe when he is depicting not globe?
No, he said ball.
Ball, okay.
Ball, yeah, it's different, not globe. Ball.
I would argue because globus in Latin, it is a ball.
Well,
just a ball.
Yeah.
But still, he is talking about few thousand miles.
Local.
In this is not heliocentric model. So
he's teaching us celestial navigation.
Okay, but
yeah,
not globe celestial navigation for sure.
Well, I don't know. He's teaching us what to do with an angle. Doing lots of stuff with an angle in 69 miles. Here we go.
The coordinates for both of these are here. The observer's angles to the star are over here. The purple, this is the elevation angle. The green is the co-altitude. This black line shows the shortest surface path between the observer and the GP, and that's this distance over here.
You've got this angle here between a blue line and the black line, but you've just said the black line is the shortest distance, and it's an arc distance. So how can you have an angle measured between a straight line and an arc? I'd say that in GeoGebra, if you tried to do that, it wouldn't give you it. Or does it? Does it give you an angle to a curve? I'd say non-defined. It can't.
Yes, maybe this is some new version of GeoGebra. I don't know.
I can't get a GeoGebra to give me an angle to a curve because it just says no. Computer says no. But hey, maybe.
And this number tells us how many miles there are for each degree of co-altitude. And this
did you
co-altitude
show them guys
is the
like
angle
that?
that we're after,
Get your
because
whiteboard out
it's
and show
this.
them guys that horizontal is, or vertical is perpendicular to horizontal?
Well, yeah, it is, isn't it?
I know, but did you show them though?
I gave him
you
some.
put the
I gave
laser
him
level up.
No, I gave him an elevation profile in the Chaiki debate. Or
You should pop the whiteboard up, show them how it is, and then let them show us how it's not.
yeah, well, that's what PT did. I was saying to everybody in the concept of understanding what 1 degree change over 69 miles is. What I did was I drew a line 69 miles because that's a distance. Then you say that's a horizontal. And then at each end of that horizontal, you can have a perpendicular and measure an angle. And the change in angle is over 1 degree over that distance of 69 miles. So there's an angle measured at one end and an angle measured at the other end of a horizontal. And that's it. You've just got two angles, one at each end of a 69-mile straight line. That was what I said, and Flat Earth Math he's done 2 videos on that so far. Nathan Oakley's got pissed off about us saying that you can do fuck all with an angle, and PT's now doing this video.
No, I'm just curious about this horizontal or vertical is not perpendicular to horizontal thing. Yeah, from the Chaiki debate. Like, I mean, you or me or anyone could show that all day happening. I don't know if I've ever seen them show it happening or not happening. Not being perpendicular.
Yeah. Well, Chaiki chose to particularly how to solve that one by misunderstanding what a horizontal is. So that's how Chaiki managed to solve the perpendicularity problem of vertical and horizontal. By just going on horizontal. I don't know how well it's going to work for many of the other blue marble scientists. Oh, no, actually, sorry, Chaiki was not a scientist. So I don't know. I really don't.
Some of these guys think I'm a scientist while I'm doing my janitorial duties. It's weird. But yeah, I'd love to see vertical not being perpendicular to horizontal. That'd be awesome.
Well, that's what they have to show. We need the black swan. We need the black swan of a horizontal not being parallel to the plane of the horizon. And we need a black swan showing a vertical that isn't perpendicular to horizontal, or a horizontal that isn't perpendicular to vertical, or a vertical that isn't perpendicular to the plane of the horizon. And that's any one of those we're after. Because obviously we can prove that every one of them is. I was saying that I might be willing to do a GoFundMe to go on a worldwide hunt for the horizontal that isn't parallel to the plane of the horizon. So we could start up a GoFundMe, and obviously you'd have to go to beaches, wouldn't you? To see the true horizon. It could take me level, and I'd just go to beaches, go for a world tour around some of the best beaches to go and check that the horizon is actually parallel to horizontal. I'd take a level or something to the beach. Could get a glass as well, like a cocktail, and hold that up as well.
For me, it would be easy. Just take plumb bob, to hang plumb bob in front of camera, and camera is directed into horizon, and check if this plumb bob is perpendicular to horizon.
Yeah.
It's true horizon.
Yeah, I could do that. If anybody wants to send me on a worldwide tour of all of the prime beach locations. Wait till the summer. Obviously, I could do that. I think. Maybe other people can do it. We get somebody else to check. Anybody else just check. See whether you can find it. Do it yourself. We could do it like a big... we could do everyone, right? If we just get everybody out there to go and do it, just to make sure. And then we might find somebody that can help us out. Let's go through PT's video, eh? Let's give him a chance to see.
This angle, together with the radius, that tells us how far away we are from the GP of the star that we're looking at. So why are we getting 38 miles per degree? Surely this should be 69.
So that 69 miles, what's that look like?
Well, I'm glad you asked, Bev, because the other thing that we rely on for this celestial navigation to work is parallel light rays. And
see, this is where PT's going a little bit wrong with it and laying everybody out. What I was talking about is, what does the 69 miles, when everybody just thinks about 69 miles? Because I wasn't talking about celestial navigation here, PT. I was talking about a 1 degree change of an angle over 69 miles. And when I said, what does 69 miles look like to somebody? What does it look like? What are you thinking of? When people think of 69 miles, what do they think of? PT's drawn a curved line there. So whenever you think of 69 miles, is that what you think of? I don't.
And by the way, he's contradicting himself now, because previously he said about local distance to the star, and now he is talking about parallel rise. So this is contradiction, because if star is close and small, this rays would diverge. But in a heliocentric model, the stars are very distant and they are larger than the globe. So this, what we can see on this picture, it doesn't depict a heliocentric model, but now he is talking about parallel rays. This picture contradicts that, because imagine that these rays are going everywhere and they are reaching this globe or this ball not in a parallel fashion. So his picture has nothing to do with what he is talking about, because now he's talking about parallel rise.
Well, he might change. He might change, but he's gone back to me asking people what do you picture whenever you think of 69 miles. That's it.
But
it's a straight line, isn't it?
Yes, but still he is doing false equivalence. Maybe he cannot see that, what he is doing, that he is showing wrong picture for his model.
Yeah. Well, I'm just trying to point out to PT as well, and to anybody else that's thinking 69 miles is a straight line. A straight line, not curved. So that's what I'm trying to get people to picture in their head. What do they picture when they imagine 69 miles? That's it. I wasn't talking about celestial navigation, but PT's gone to celestial navigation whenever we're talking about 69 miles.
And we're never going to get parallel light from a star that's this close. So let's move it away a few hundred light years.
Wow.
And now that the star distance is much further away, we now get the familiar 69.1 miles per degree.
It looks like a triangle, right?
No, it's 3 lines, isn't it?
In case there's any uncertainty, let me explain these lines. This red line, this is a vertical line from the GP to the star. This dark line, this is a vertical line from the observer to their zenith. And this blue line...
I'd love to know when they
this is
measured that 69-mile thing. I mean, they really come with nothing. Remember that spherical excess thing I brought you that one day? Yeah. And I was like, yo, take a look. And you knew right away it wasn't even a measurement because there was too many decimals after the arc second or something.
By the way, can you see his trick now?
Yeah.
He is making these 2 parallel lines, and they are supposedly coming from the same star. So what he is doing with this star? He is making it larger and larger with distance.
Uh-huh.
I still ain't seen a real spherical excess measurement since.
No, it doesn't. But I am just depicting what he is doing, which is not shown because the star is no longer in the picture.
Well, geometrically, right, he's got a ball and he's got 2 lines that are parallel.
Yes.
That's
so
it.
They have to, if they were going from the same star, it means that this star is, I would say, at least size of this distance between 2 lines. But in first picture, he showed this star as very small, only on 1 line. So this is the trick. Inversed perspective.
Well, really, all he's got is 2 straight lines. Because that other one, the black one, isn't a straight line. So he's just got 2 straight lines that he says are parallel. But you've got no way of knowing that they're parallel. It's just an assumed parallel from 2 different positions. That's it. He's got no ability to measure an angle. So, well done. You've got 2 straight lines. Definitely not a straight line in between them.
Yes, of course. That's correct.
Okay.
Impossible to measure angle.
Line of sight from the observer to the star. Using this line of sight gives us the altitude angle and the co-altitude angle. It does.
What's the angle there? You can't have an angle to a curve. Sorry. Not allowed. It's not a straight line. That's why I was saying at the beginning, PT, when in order for you to start off, you start off with a base line, a straight line. That's where you start off from. But you've missed that completely. You've just gone and drawn 2 lines, presumably parallel. No way of knowing whether they're parallel or anything.
Doesn't matter which we get first. Either gives us the other as the complementary. And that's just another way of saying that they add up to 90 degrees.
People I've talked to did have a different understanding because I don't think anybody's ever showed them the simple geometric version of how this works.
Does that same angle measurement carry on to the land?
That's where it was initially measured, 69 miles.
But what I'm saying is, like, if you go east and west, you still come up with the same angle, don't you?
I don't know. You have to go away and towards it. That's how the story goes.
As you can see, 69 miles per degree isn't limited to a meridian line. And because we're dealing with the distance between coordinates, it doesn't matter if the observer is on a mountaintop and the GP is out at sea.
In order for you... Really? Because when I said that they measured it at 69 miles, that had to be a horizontal, same elevation. Not different elevations. But hey, I mean, this is different. When I was talking about it, PT, this is where we might get mixed up. I was just talking about on land measuring 69 miles as a land-based measurement, horizontal, and then measuring an angle at each end. And I know Flat Earth Math got upset about it, and he made a straw man argument to, then he had to make rebuttals to his own straw man arguments. It seems like you've drawn a ball, but I was just talking about a 1 degree change of angle over a 69-mile distance. The 69-mile distance is a straight line. Being at the same elevation is a horizontal. And that's the line that you would use as a baseline in order to establish an angle. To get me into that next part, I have to know what the fuck I'm doing with an angle. Because even when I know here that, right, you travel 69 miles and you can measure an angle change 1 degree. What does that mean?
I find myself here at 30 degrees north on the prime meridian, and let's say that the North Star is fixed directly above the North Pole. When I travel north by 69.1 miles, the co-altitude angle will have reduced by 1 degree, hence 69.1 miles per degree.
I've never known anybody that keeps measuring 69 miles as they're going towards it and eventually ends up with the light in the sky above their head. And then they can keep going 69 miles and it starts dropping in the opposite direction. I don't know of where that occurs.
So how do I know that this arc length equals this value? If I take 40...
You're using GeoGebra.
Yes, he's using some model.
Like, how do you know it? Well, you're using a model, putting some numbers in, and you're going to get some numbers back out. What I was saying was I don't know anybody that's done this, meaning I don't know anybody that's actually measured 69 miles on a horizontal and then measured a 1 degree change of angle at each end of that 69 miles that's been measured. Who knows? If anybody actually has been out there and measured 69 miles, like it actually, in reality, not like on a computer model, in reality measured 69 miles on an even elevation, because it's a straight line.
3 degrees and convert that to radians. So times pi divided by 180. And then multiply that by the radius. That should give me 2971.2. And that's this value here.
I talked about this, the two people so far, well, today. And both of them had a different idea of what the geometric picture looks like, but was sort of unable to show what the geometric picture would have looked like. I can't see the point in measuring angles to lights in the sky.
Sorry, that was bugging me. That shouldn't say 180, that's 90. So the only thing left to talk about now really is the circle of equal altitude. And if I've measured my co-altitude angle to be 27.5 degrees.
See, this is the difference between telling people what it means, and because equal altitude, when people think of that, you think maybe you've been on a plane and you've been traveling at 30,000 feet altitude. So an equal altitude would be 30,000 feet all the way along, right? Without going up or down or closer to the ground or anything like that. That was what you would consider as an equal altitude. A water level is described as a tool for establishing an equal altitude. Now, it calls that a horizontal condition. And as we know, horizontal is a straight line, not the horizontal like Rumpus was talking about, the circle one, but the actual straight line, equal altitude. Yeah, I know. That's what I'm saying, Peter. You don't explain this, but I will for people. So what he's talking about there, where he says equal altitude, a circle. It's not a circle because it's on a sphere, a ball. So that would be a position where you measure the same angle to something that's deemed to be up above you. That's all it means.
And I spotted another trick here. As we can see now, this red line, before it was at the so-called North Pole, and it was vertical. And now he is tilted, but he depicted these lines as parallel to each other. So this line with, let's say, at North Pole line position should be parallel. This red line should be always parallel because rays are incoming parallel. So if he is considering Polaris, this red line and all this blue line should be parallel always to this North Pole line, vertical. And it is not on his picture.
Well, can he not just use any light in the sky? He does seem to think, well, I thought it was for, I thought you had to either walk towards or away from Polaris, wherever you're dealing with this 69 miles for 1 degree. But he said you don't have to. And I presume now that seeing as he's not even looking at that light in the sky, that you can do it in any light in the sky.
Okay, but still, for me, it doesn't make any sense.
I know it doesn't make any sense. Like I said, I can't understand why people are measuring angles to lights in the sky anyway. It bears no relation to anything for me. And yeah, these definitely aren't looking at the same light in the sky. So I presume any light in the sky will do. Or like whether he's taking Rumpus rules of what the vertical must be, and then these become verticals, but then this one isn't vertical. I don't know. It gets very confusing. I know it does. It's not got long anyway.
Then I can multiply that by 69, and I'll know that I'm about 1900 miles away from the GP, and that's somewhere along the circle. And this is a circle. You could draw your own simply by pinning one end of a length of string to anywhere on a ball, while wrapping the other end around a crayon. Before you eat the crayon, pull the string tight and draw yourself a circle. Anyway, that'll do for this video. I hope you found this geometry interesting, and if you want to see the script, I'll leave a copy on the GeoGebra website for you to explore. If you're feeling generous, hit those like and subscribe buttons. Thanks very much for watching, and I'll catch you later.
Oh, what's that? Blue Marble Science Parallel Horizontals. Well done, Petey. I hope you did well there for the globe. For the globe!
And of course, he made common mistake because distance in straight line, as you depicted on your whiteboard, is changing 1 degree per 69 miles distance without changing your angular position to the star. But on the globe, we are changing as we are moving away from the star, let's say, we are changing not only distance, we are changing an angle also. And he is missing the point. This is what many people noticed. This is not me only, but he should add next angle to that according to the curvature. So he is using horizontal line measurement of difference in angles, and he is completely ignoring curvature, because otherwise he should add this curvature and these measurements would be completely different, and he's not doing that. So this is, for me, this is just a trickery. But he is saying that this is on the globe, then he is using trigonometry, which is utilizing, of course, triangles with a straight line. And then he's saying that this is on the globe, ignoring this angular change with the globe, because, as I said, if we are moving away, we are not changing only horizontal distance, but we are changing an angle if we are on the ball, and he is ignoring that. Maybe he cannot see that. I don't know.
Well, I would say, yeah, a couple of problems I see, Darren. The 69 miles is a straight line. Problem one. Number two is that in order to measure an angle, you need two straight lines, and you only had one. That one was an assumed parallel, and that's your other problem, that even if you did have a straight line, you'd just have parallel. So I don't know where and how you do any geometry of what. I mean, I know you gave us a model of a ball that you can put straight lines on. I don't know what geometry you were talking about. I really don't.
Yeah. His baseline is curved, so and he said on YouTube chat that there is no trigonometry here.
No, they've got no triangles. They've literally just got straight lines.
But still, we have changes with in degrees. We should have anyway, and additional change according to the curve, and he's ignoring that, and he's not addressing that. I would say that he will never address that. This is just a mistake.
Darren, Darren is useless. Blue marble scientists, particularly the new ones that we've just got round here, obviously Starkodder, telling, he's telling Darren about the circle. I have to tell you about that one as well, Petey. Although you said putting a string and getting some crayon, that's not a circle. A circle has a radius, and you can't draw a radius to draw a circle on a ball. It's just not a circle. But I'm guessing these are basic, simple elements of geometry. And you may call it pedantic, but you can't draw a circle on a ball by putting a piece of string and a crayon. It just doesn't work like that. That's not geometry. And again, I have to point out that I was talking about a 69-mile horizontal and an angle at each end. The very fact that somebody has decided to put that on a ball, how does that relate?
And Pete, he admits that he didn't address the dip. So I am right, and he said that I just use the co-altitude angle. That's all you need. So all you need is ignore curvature. That's what he said.
Ignore the curvature of the baseline that you're dealing with.
Yes, yes, yes. So simple.
Well, that leaves you an even bigger problem because you've just got 3 straight lines, and you can definitely do fuck all with that. Literally nothing. What's he meant to be doing with it? Geometrically, what do you think you're doing?
There is no. This is a rectangle. So yes.
Well, you can't make a rectangle, can you? The best you can do with this would be to prove the triangle axiom, axiom 12. That'd be the best you could hope for, in my mind. Parallel lines.
Yes, because if these lines are parallel and baseline, we ignore curvature of baseline, it means it is straight. That would be some kind of rectangle or rhomboid or whatever, but not triangle.
PT says I was addressing you can do fuck all with an angle. How? You need to address the horizon. No need to address the horizon when you can measure to the star or directly. Well, that was the thing. You can measure an angle to a star. Yes. But what can you do with it? Exactly nothing. I don't know what you've claimed you've done with it. Unless you just said you've put the angle on a model.
Well, they claim you could do a whole bunch of stuff with this. You can get distances, directions, the other, you get 3 of those angles, you're good.
Well, the claim is you can do fuck all with an angle, like one.
Yeah, no, they need a book, a whole bunch of shit, but once you got the angle and, all 3 of the angles and then all that shit, one angle, I don't know. You might be able to do something with it. I don't know. I don't know what. Get the angular size or something, maybe.
No, without any further information, you cannot do anything with an angle. So you have to have previous knowledge or previous assumptions, pre-assumptions. So this measuring angle measurement would be that part of some process and not the first.
Would you consider a horizontal line to be an angle, 180 degrees, or no? You definitely do mad shit with that.
Yes, you can measure angle from horizontal to the star.
No, I'm saying if you just have a straight line, do you consider that an angle? Like 180 degrees?
No. Straight line has no angle to itself.
Yeah, it's even defined as not being an angle.
No doubt, no doubt.
Specifically wrote in there in the It's one of Euclid's Easter eggs, let's say. So technically, 180 degrees isn't an angle.
Because there is no inclination.
That's crazy.
You have to have inclination. One line to another. And they would intersect at some point. So if you have straight line, or as you said, 180 degrees, there is no intersection point. So there is no inclination and intersecting point.
Yeah, it says here, like a plane rectilinear angle is the inclination of two straight lines to one another which meet together but are not in the same straight line. So they can't be meeting in the same straight line. So a straight line isn't an angle. It's got to be two straight lines, and they've got to be meeting together, and they can't be meeting and sharing a common segment. That's
crazy. So you could have you can't have 180 degree. I've always thought of it as an angle, but yeah, that's neat.
Because this is convention, because this is half of the circle, and we are measuring angle by means of the circle. So it creates really half of the circle, and because the circle is divided into 360 degrees, so yes, technically, if we are considering this as a circle, it is. You can say that this is an angle, but this is just only in reference to the circumference, not to the diameter, let's say.
Yeah. Yeah, it's tricky, isn't it? Within Euclid, without needing the number, then there is no angle there because it is a straight line. But in reality, you have to depict it as something. You can't have it as not being an angle. Like you can't go from on a scale from 1 all the way around to 79.9 and then no angle and then 80.1, 80.2 degrees and then the angle coming back again being bigger. You have to actually have it in reality, but technically within the definitions it's not an angle. It's a straight line. I mean, why do you need to give it an angle? Where would you put the point that the angles meet anywhere on a straight line? I mean, where would you do that to measure it?
I mean, I understand that, it's in a definition, but there's this guy Ruhef told me definitions are meaningless. So I mean, where do we go from here now?
It's not just him now. That's spreading. Everyone, you can make it up themselves.
Don't listen to Ruhef.
Yeah.
Okay, I have to go to bed. Good night, all.
Okay,
Thank you very much.
Thank you very much.
Night, night. You guys are bugging with it, Bev. I feel you.
Yeah. Darren's just saying a load of stuff because we have these sophists. Most people are going to be meeting sophists whenever you're dealing with this conversation and people like this. Darren, come on in. Come and have a chat anytime, mate. It's getting a bit old just listening to people spouting shit about stuff. I mean, we know the blue marble scientists have been fictional. They're not real. You may have imagined that you were some sort of a super character, but now you've just found out that your entire thing that you've been fighting for, blue marble science, has said it's mythical. Doesn't exist. There's no such thing as the blue marble science. There's no science involved with the blue marble. It doesn't exist. Completely mythical. Anybody got any final words? Gonna get a Buster song ready. Get ready for tomorrow. Free for all Friday tomorrow. Should be a good one. Do a wisdom. Anyone? Final words? No? Okie dokie. Thank you very much for joining. Free for all Friday tomorrow. Who knows what's coming? Anybody wants to go over any of these things that we've talked over? Anybody brave enough? Perhaps Darren. Darren, get yourself a script out. Record it. Send it over tomorrow. Let's see what's going on with that. Might have to have a bit of a chat about that. Kevin said he wanted to have a word with it. Okay, thank you very much. See you tomorrow. Free for all Friday. That might be good.
It is probably the single most important mathematical idea of all. The notion of proof by circle and line or ruler and compass construction means that geometry can be known about in a way that is different from knowing about physical things, and so makes geometry epistemically differentiated. Furthermore, starting from circles and lines alone and constructing a relationship using circles and lines alone makes the conclusions certain in a way that nothing else was at the time. In geometric reasoning, the argument and the conclusions were made supremely clear and evident to the senses. Indeed, the concept of proof, a mechanism that gave a warrant for claiming geometry to be perfectly and absolutely true, made geometry the very paradigm of what we mean true and certain knowledge to be. In effect, in our understanding of nature, true means true like geometry is true.
Come go with me. Open your mind. Was all I ever knew. Finding the knowledge of the real world starts with the point of which has no parts. These are the axioms of life.
True.
And I take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I find the proofs in reality. They were right.
We call this
We know that they were right.
True. We call this proof. Like geometry is true.
Starting with circles and lines alone, constructing the nature of what's known.
We call this proof.
Conclusions are clear and the evidence seen. This 3D space works perfectly. And I take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say. I find the proofs in reality.
Geometry is true. Perfect. Absolutely.
And all around you is sinking sand. You have a place on which to stand. Foundations were already built for you.
Absolutely true.
Open your mind. And I'll take my chances with the older ways, hearing the words of what the ancients said. They say my words sound like sorcery, but there's wisdom in all honesty.
True.